similar number of questions, 13 or 14?
Almost pretty much similar, 13, 14, or it won't cost 15.
And the time we have 4 hours.
Oh, yeah,
Basically,
1 hour for each subject, I guess.
1 hour
yeah.
for one subject.
Sir, did you think that there is sort of time,
There is
sir, like 14 to 15 question in 60 minutes, and we
Acha.
have look of all subjects like stat.
Okay. So see, if the number of questions are very less, if I say 6 or 7, the weightage for each question will be very high. And
Sir,
if
I think
you
that actually 10 to 11 question are enough, even 12 or enough.
see, frankly speaking, there will be only 10 questions, but including subparts, that may go to 15 or so. So subparts are like, see, the thing is, once you understand the question, answering subparts will be very easier. Okay, you will
So
get
each
that
question will have sub part.
yeah, some 3 to 4 questions will have subparts of some, maybe say 3 subparts or 2 subparts. So see, whenever you understand the data, answering those 3 questions will be once you answer one question, answering the rest of the 2 questions won't take much time. It's a part of comprehension kind of thing you can consider.
Yes, sir.
So yeah, we do consider that you have only 1 hour and we will prepare the question paper.
Okay, sir. Okay, sir.
So,
Yeah.
so if my polynomials is weak, do you have any? Uh, could you suggest something that I can so that I can improve on that?
Polynomial, can you be more specific, like in which part of so understanding polynomial, or drawing a graph of polynomial, or
So I
finding the
think
roots of a polynomial?
mainly dealing with the equations and roots and all.
Okay, so you want to suggest me some textbook, or
So so what can I do to improve in that area?
uh, in this particular course, whatever you are seeing, each and every question starts with data, and we will ask the question in terms of mathematics. So the
Okay.
main and foremost thing what we expect from you is how you convert the data into mathematical terminology.
Okay, sir.
So once you get that, I think from there you have to start it from there. So whenever
Okay.
you read data, what max lies behind that data you should extract. So that is what we expect.
Okay, sir. Thank you, sir.
Yeah, start
So,
from there and proceed.
sir, in the qualifier exam,
Hmm.
so can we expect some similar type of questions from the practice assignment or the mock test?
Of course.
Okay, sir.
How many
Because in the mock test,
Hmm.
I got some similar type of questions. So I thought that maybe in the qualifier also I will get some.
See, of course, not the whole paper, but
Yeah. No, I'm not talking about the whole paper, but
yeah, you will see a similar kind of activity question, similar kind of practice, similar kind of grade.
okay.
Sir, I have a doubt in like slope, how to like find a slope of a tangent if a polynomial function is given.
Slope of a tangent.
Yeah,
Did we ask that?
like
Let me
slope
check.
of the tangent can be 0. Yeah, it's a question, mock test
That's the
question number
turning
3.
point. It is parallel to x-axis. That will be 0 slope, right?
Okay.
Turning points. Turning
Maybe
points
we
will
discuss
give.
slope at turning points only.
So I had a question on mock test question number 6.
Yeah, let us start then.
Yes.
Let us start by taking questions from mock test, and in between we can discuss some topics.
Yes, sir. Question number 6 and
3, 4, and 6.
How many questions we will expect in qualifier? 15 earlier you were telling
Same as
15 like that.
similar kind of thing. Similar kind
How
of
many number?
exact number I should check the question paper.
Just asking around 15 or like that?
Around, more or less 15.
Because yesterday time was not sufficient for me actually. I'm able to answer the questions, but time is not sufficient.
Me also, sir. Yes, sir.
Oh.
But the
Because I'm
thing is,
able to solve, I was able to solve around 10 questions. After finishing the test, I did for 15 more minutes to solve all the 14 questions. Almost I got the correct answers, but time was not sufficient for me. That's why I'm asking.
but the thing is, for maths, you will save up some time in English, no? That time you can utilize in maths.
You need some time in statistics also.
Okay, so we will discuss those at the end of the session. So how we proceed to answer few questions. I have discussed many shortcuts whenever a question comes up. We will discuss few more shortcuts how to approach on a question. Before that, let us take some questions from mock.
This is question number 6.
Question number. Can you read out the question, please?
Yes, sir. The set comprehension question was in a school out of 400 students.
Okay.
In a school out of 400 students,
Hmm.
300 students opt for at least one subject out of biology, math, chemistry, and mathematics.
So 400 total students, right? And it is given that
300 at least one of the three subjects.
Correct. So 300 is at least one of the three subjects.
120 for biology.
120.
120 for biology. 150 for chemistry. 200 for maths. And 30 for all the three intersection, or opt for all the three. And so here it is asked that find the number of students who opted for exactly two subjects. Here 300 is told that at least one of the three subjects. That I can understand.
Okay. Find the number of students
We could just draw the Venn
who
diagram.
opted exactly, right?
Exactly two of the two subjects.
Okay, so this is the data. It is given in the question, right? So from this data, what we try to do is, what we know is when we convert this particular data into Venn diagram of containing taking three sets, and if we can draw the Venn diagram, and if we can give particular numbers, so that particular number represents the number of students present in that particular region. If I can come up with this Venn diagram, I can able to answer this question. But coming up with that particular Venn diagram is the task. So now, so this is data we have, and what I wanted to convert is convert this data to is into my mathematical terms. So what I do is I take biology, number of people taking biology as my set B. So I say set, this is a set B where in this particular set contains the students who opted biology. Okay, so this particular set contains all the students who opted biology. It doesn't, this tells me regarding only biology. It doesn't tell me anything about chemistry and maths. So there can be students in this particular set B who opted for chemistry also, who opted for all the three also, everything. Similarly, I will take another set M, which is the students who opted maths, and some other set C, the students who opted chemistry. Now I have three sets. I can draw a Venn diagram based on this three sets. So this is biology, this is maths, and this is chemistry. Now identify what region represents So we have 1, 2, 3, 4, 5, 6, 7, and outer one is 8.
Yes, the total students are 400. Did I say
Yeah.
that? Oh, okay.
So this is universal set I have. This universal set means all the students in that particular college. So that is our universal set. So identify that. That means the cardinality of U is 400, right? So when I say cardinality, it actually tells me the number of elements present in that particular set. So U is the set of students who are in that particular college. So cardinality of U is nothing but the number of students in that particular college. So the total number of students are 400. So once you get this, the second statement is 300 at least one of the three subjects. So when you see this region here, so identify the region which represents at least one of the three subjects. So is this particular region will be in my that thing or no? Like when I say that thing is like, so the students who are present in this particular region have chosen at least one subject or not?
Yes, sir.
Yes, sir.
Yes, sir.
Yeah, this region is basically the students who have opted only biology.
Yes, sir.
Only biology. That means that student has opted for biology.
Exactly one subject, no? It's
This is
exactly
exactly
one
one subject.
It is exactly
Yeah,
one
given
subject, sir,
exactly
not
at least,
at least one subject.
okay. So see, when I say at least one subject is equal to one students who are choosing one subject plus students who are choosing two subjects plus students who are choosing three subjects, right? At least one means at least the student should choose one subject. That means if he has chosen one subject, he will fall into this at least one category. Even if the student chosen two subjects, he will fall into this category. Yeah.
Okay, exactly is the subset of at least one subject.
Yeah, right. At least n. So when I say a natural number n, it should have and that natural number is at least 1000. So n can take 1000, right?
Yes.
Right. So at least is like minimum bound. So at least I have to do this work. That means if you
Sir,
have
for
done
at least, can we write less than or equal to?
right a greater than or equal to.
Greater than equal to.
So when I say P is my particular task, P is okay. P is number of subjects chosen. So P is at least one means P should be greater than or equal to 1. Okay. So at least I should complete treat it like this. At least I should complete this task. That means if you done that particular task, that means you have satisfied your criteria. So at least one subject is one subject. Either the student is chosen exactly one subject, or student is chosen two subjects, or student is choosing three subjects. So this particular region is exactly one. Even this particular region is exactly one. Even this is exactly one. Now inside thing. Okay, this region is exactly 2. See, this particular region represents the students who have chosen biology and chemistry. So both it contains in this particular set biology, also it is containing in this particular set chemistry. So that means this region represents the students who opted biology and chemistry.
And chemistry.
Similarly, this
Biology and mathematics, I
biology and
guess.
mathematics alone.
Mathematics
Only
and
two subjects. This
chemistry.
is only two subjects.
Okay.
Final thing is this middle region,
Which is given.
yeah, which tells us that in this
30.
particular region represents the students who have chosen all the three subjects, all the three biology, mathematics and chemistry. Now at least one subject is union of this green region plus purple region plus this light blue region. So that means we
Yes.
have given you that this is nothing but, this whole thing is nothing but B union M union C. Observe, this particular thing is B union M union C. Right? So this particular cardinality is given as 300. And cardinality of each set is given to us. Something like biology is 120, maths is 200, chemistry is 150. Right? Yeah. And also it is given that B intersection M intersection C. So students who have opted all the 3 subjects is given as 30. Right?
Right, sir. Right, sir.
Also we know this formula, well-known formula of set theory. When we have 3 sets, cardinality of B union M union C as cardinality of B plus
B
cardinality of
plus M plus C
So this is not mod, this is
minus
cardinality symbol, okay?
cardinality.
And students who are confusing, this is cardinality symbol. So this minus cardinality of B intersection M minus cardinality of M intersection C minus
C
cardinality of
minus
B
C
intersection
B intersection C.
plus cardinality of B intersection M intersection C. Okay, now let's get back to the question. What is the question actually? So what are they asking us? Find the number of students who opted exactly 2 subjects. So here the question can be of different kinds. So here we ask you exactly. We can ask you at least, or we can ask you at most. So what is at most means? At most 2 subjects. What is this?
Sir, maximum 2 subject.
Yeah, maximum of 2 subjects. The opposite of at least.
1 plus
It's the opposite of at least. So when I say at least 1 subject, it implies me that either 1 subject or 2 subjects or 3 subjects. When I
Yes,
say
sir.
at most 2 subjects, it means that either it is 1
There
subject
should be
or
at least 2 subjects.
it's like an upper bound, upper maximum value. Okay. So yeah,
Also, for
as
at most 2, we will have the pink region and the green region, right?
yeah, for at most 2, yeah, right. So this particular purple region and green region.
So,
Purple and
so at most 2 will also include the outer white region, right?
Outer white region is, yeah, outer white region also, right.
Okay, sir.
So please try to explain one after other exactly after at least and at most one after other.
Right. Okay. So at least we have discussed. The question is about exactly. So when I say when we see this exactly term, we have to see only the students who have opted only 2 subjects. Only 2 subject means which region?
sir, purple region.
Yeah. So we have to find this particular purple region. So this plus this plus this.
B intersection C and M intersection C. B.
So this particular purple region we are going to get when we add B intersection C. So B intersection C means this particular whole region I
This
am adding.
okay, we have to subtract.
Yeah.
Region.
So B intersection C plus C intersection M plus M intersection C, M intersection B.
B.
So when I am taking these 3 regions, observe that this particular inside region is added thrice.
Yes, yes. Blue region also.
Yeah.
Get added.
Light
So we
blue
have to
region
subtract.
is being added 3 times.
Yes.
So one from B intersection C, one from C intersection M,
And
and
one
one
from
from
B.
B intersection M. So I
Yes.
don't need that blue region, light blue region. So what I have to do is I have to simply subtract that particular region
3
3
times.
times. So I guess this is where the mistake might happen.
Why is
Yes.
it 3 times and not 2 times?
Hmm?
So, why is it 3 times and not 2 times? Because we need it once, right?
We don't need, right? We don't need that region at all.
Oh,
We
it's
need only
exactly
purple
2.
region.
It is getting added 3 times, so we have to subtract it.
So see,
Sir,
when
so
you
is
say
it, are we doing exactly 2 right now?
right, exactly
Oh,
2.
okay, okay, okay.
The question is about exactly 2, right? Find the number of students who opted exact.
Yes,
So,
sir. Got it,
but
sir.
this light blue region is actually the students who have chosen all the three subjects,
Yes.
which is not exactly true. So that is why we have to remove this region from this particular B intersection C plus C intersection M plus M intersection B region.
Okay, okay.
So when I take these three regions, I am actually taking this particular inside region 3 times, but I don't need that region. So I will subtract that particular region 3 times. So ultimately our purple region is this thing. So we have to compute this. We know B intersection M intersection C. We have to find B intersection C plus C intersection M plus M intersection B ka cardinality. So for that we will use this particular formula. So we know this is 300 and this is 120, this is 150, this is this is 200, this is 150. So this particular thing we want. So what I will do is this, I will write it as minus of answer. This is the answer we need, or not the answer. Okay, I will write it. So this is B intersection M plus M intersection C plus B intersection C. And we know this. This is 30. So from this we will get cardinality of B intersection M plus cardinality of M intersection C plus cardinality of B intersection C is equal to, if you add all this, we will get 470 plus 30, which is 500.
500.
200. 300. This 300. So you will get 200. Okay.
Yes.
Is my calculations correct?
The answer was 110.
Yes, sir.
Answer is 110.
Sir, answer is
Yeah.
100.
So we'll minus
This
3
is not,
times
Just 3
30.
times 30.
this is not the answer. We got
Is-
the
yeah,
cardinality of B intersection M plus cardinality of M intersection C
You have
plus
to subtract.
cardinality of B intersection C. Actually,
Oh.
this is, we are adding this,
Now we have to subtract
yeah,
it.
purple region with
Subtract
3
these.
times of this blue region. But we
Yes,
don't
I
need
am.
this blue region. We have to subtract this blue
3
region
times
3
B
times.
intersection M
Okay.
intersection C.
So once you subtract that, this particular
90.
thing minus 3 times of 30. 200 minus 3 times of 30, you will get 110.
110.
So this
Correct, sir.
particular 110 is the number
Sir,
of students who opted exactly to.
So this
Exactly.
200 also is a, if you 200 is exactly means greater than two subjects. At least two subjects is 200 also, no? If they asked.
At
No, no,
most
no.
two subject, na sir?
At least 2 subject.
At most two subject, na sir? 200.
Yeah, let us do now at most. So when I say at most 2 subjects.
Sir, ये,
The 200 is the,
3 into
at least.
Someone is asking.
sir, 3
Excuse
into
me, sir.
90, 3 into 30. Why we multiply with 3? Can you explain it?
Just now, right? So this part, see, observe the regions. When you have the Venn diagram, just
Yes.
find the region what we have to find. So
We
this
only want the purple region.
we want only the purple region.
Yeah.
Okay. So see, okay, I will write it slowly. One thing I will write, do it for other two. So when I want this purple region, this particular purple region, what I have to do? This whole region minus
minus
Minus.
this whole
Minus
region.
that
Yeah.
blue region.
I got it, sir. Thank you.
Okay.
Yeah.
From there you can get it. So you
Sir,
can do this for this and for this also.
Sir? Sir, at least one subject it covers all the diagram, na? All the whole diagram.
At least one subject is nothing but B union M union C. This particular green with purple with light blue.
Okay.
So let us do this at most 2 subjects. At most 2 subjects is either the student is choosing 0 subjects or
1 subject or 2 subject.
Or 1 subject.
1 subject or 2 subject.
Or 2 subjects. So
That is
what
less
will be
than or equal to, no?
now give me the region of our required question.
So purple and blue region.
Okay, when I say B, M,
Sir, U minus the whole union.
It as well.
U minus the whole union.
Yeah.
That is 0 subjects.
That
Zero
is zero
subjects.
subjects.
No,
And
it will be U minus B
Okay,
intersection M intersection C.
Okay, we will go
Sir,
by
any
subject.
two intersection.
Yeah, we will go subject by subject. So we will first shade which region represents the students who have chosen only only 0 subjects. Matlab, they haven't chosen any subject. So which region is that?
The outer area, the
Outside
box
region.
one.
The outer area.
Outer region. This region, right? All this region is actually the students who haven't chosen any subject or they have chosen 0 subjects. Now let us shade one subject, only one subject. This is like only one subject.
B, M, and C, but we have to remove those intersection part.
This one, right?
Yes, sir.
This,
Yes,
Yeah.
sir.
Yes.
this, and this.
Yes, sir.
Union C.
Now two subjects.
The intersection part, BM, BC, and
Without including
Yeah.
all three intersections.
All three intersections.
Now once you got this, as I said, or you know this logic, right? Or is like you should add those regions, and is like you should find the common in the region.
yes, sir.
As we said, or that means this red region,
Union.
including this green region, including this purple region. So what we
Yes,
have
sir.
left with is
Sir,
except this intersection region, all B intersection, M intersection, C, remaining all the region should be covered in this at most 2 subjects thing.
Yes, sir.
Sir, can you repeat once more time or and
See,
what?
or is basically you have to add the regions.
Okay.
Okay, and is 0 subjects and to 1 subject. So which region will be that? So students choosing exactly 0 subjects and students choosing exactly 1 subject. Will that make sense?
Yes.
So can a student choose 0 subject at the same time choosing 1 subject?
No, sir.
No, sir.
No, sir.
No, right?
Yes.
Yeah. So see the same. Okay, let me talk in this set theory things. So when I say there are 2 sets A, B, when I say A and B or A intersection B, A and B or A intersection B, these all are saying me that the
No,
element
sir.
should contain in A as well as in B.
Yes, sir.
Okay. So this particular region
The
represents
intersection.
intersection or and region. So observe which region we are shading. Actually, we are shading the common region
Common, which is
between
both
A and
A and B.
In which both A and B are included.
yeah, this A and this B. So when I say A and B, so we are including this common thing.
Okay, sir.
When I say or A or B, when I say that A or B, that means I should include this particular blue region as well as this green region. So whole thing comes. A union B is this particular thing.
Okay, sir.
Okay. Or and
Intersection also come, no, sir, in this intersection part.
intersection will also come inside this A or B.
Sir, here in the three-set problem, how do we calculate the number of students who took 0 subjects? Is there any formula?
It's like, see, you know.
I mean, yeah, I mean, we can subtract the 400 minus this total.
Right. So total students in college minus students
The intersection will be
who have chosen at least 1 subject.
Yes, sir. Basically 100.
Right. So this will be the students who have.
So can we just calculate for like, students who have at least 1 subject? How do you calculate?
See, at least 1 subject is nothing but students who have chosen 1 subject exactly, or student who have chosen 2 subjects exactly, or students who have chosen 3 subjects exactly. So all these 3 cases comes under including if you include all these 3 cases, we can collectively say it as at least 1 subject.
Yes, sir.
Okay. So that
What
is
is the answer for this at
Oh,
most?
100,
400
100.
minus 30.
300,
400
400
minus 30, 370. At most thing is 370.
400 minus 30.
400 minus 30, right?
Okay.
No, but here in the question only given the 300 is the at least 300 students have at least taken one subject. So students who have not taken any subjects will be 400 minus 300.
Yeah. So this is what students who have not chosen any subject is actually total number of students in that college minus students who have chosen at least one subject.
Yeah.
So if I subtract students who have chosen at least one subject, I will get the students who haven't chosen any subject. So 400 minus 300. So this 400 is given to us and also this 300 is given to us. Actually this red region, cardinality of this red region is actually 100. So these are the students who haven't chosen any of the subjects.
And so the thing that we calculated, the 200 thing, 200 is the answer where came. And
Yeah.
that it's at least two subjects, no?
No. See, this is actually this particular purple region and this blue region 3 times. So we are actually taking this blue region 3 times.
Yeah.
So what that region?
No, where you calculated 200, no.
I'm talking about 200 only.
Yeah, when we minus that, for that the question was exactly two subjects. I'm talking about when the question will be at least two subjects.
At least two subjects is from that intersection thing. You should subtract this particular blue region 2 times.
2 times, no? Yes, sir.
Or 2 times.
Yeah.
Oh.
So actually, what you are doing is you are adding this purple region, this purple region, this purple region with this light blue region 3 times. That is what your cardinality of B intersection M plus B intersection C plus C intersection M gives you. That 200 is actually, if I say X, Y, Z, and P. That cardinality of cardinality of B intersection M will be X plus P. Right? This is X and this is P. No? Okay, leave it. Just leave this XP and everything. So whenever you are talking about B intersection M, you are taking this purple region as well as this blue region once, right? When I say B intersection M is union of this region and this region.
Yes.
When I say B intersection C, this purple region and again this blue region.
Sky blue, yes, sir.
Again I am taking that blue region. When I talk about M intersection C, this purple region, again I am taking this blue region again.
Sir, I have a question. Suppose we are given B, M, and C, and nothing about the intersection of B intersection M, M intersection C, and B intersection C, but only the three value. Then can we find the intersection?
Intersection of what?
Intersection of B intersection M, M intersection C, and B intersection C. If we don't have been given any intersection point, this third one also not given. That the middle one.
We have to compare the sets.
So basically, like to extend this question, the point is we calculated 110, and that is the purple region, excluding the light blue region, right?
Yeah.
So if we have to find out the particular, it's a combination of all the three purple regions. If we have to find out one purple region, how do we do that?
No, it's difficult. So you need extra information to do that.
Oh, yes. Okay, that was my basic query.
No, yes. You should require some other. See, as of
sir, one general question.
The question, sir, can you repeat once only?
Yeah, sir. Before that, one general question. In your A and B, when I say A and B, it is A union B or A intersection B?
A intersection B.
A intersection B. So we are talking about the middle one, the where it is the intersection is called A and B, correct?
This one.
Okay. Yeah. When you say A or B, how do we write into formula? I mean, A or B.
A or B is actually either A, either B, or A and B. So three things. Either it is.
Okay. Can you highlight what is A or B? I mean.
A or B is whole region.
It is A union B.
Okay, A union B.
Yeah, A union.
Okay, then A union B or A or B, correct?
Right.
Okay, that is when I say A alone, it doesn't have any intersection, only pure A alone.
This thing,
correct?
this particular thing.
Okay, exactly. When you say A composite means it will be whole B and with intersection, correct?
With intersection.
A complement.
B.
If I am not wrong, you are talking about complement.
Sorry, complement. Yeah. When you say A complement, it is whole B plus A intersection B, correct?
Yeah, we have to subtract A from.
Yeah. Actually, A complement is like treat it like whatever the elements which are not in A will be in A complement. Opposite of A.
Okay, just opposite of A.
Yeah.
So when you say opposite of A, we have to consider even the A intersection B also. We have to consider, right? Because
A intersection B, in A intersection B, there are some elements which are present in A.
Yeah. So that doesn't come under complement, right?
No. See, if this is
in intersection, some element or all element belongs to A.
all the elements which are present in A intersection B will be in A.
Right.
So this particular.
So you didn't explain how at least two subjects.
Okay. Okay. So this is the A complement. Okay.
This is A complement. Okay. So whatever the region which is not
belonging to A.
Not in the region A. Which is not the region A is A complement, basically.
Universal.
Okay, sir. Yeah, thank you very much.
Okay. So this is about at most. At most two subjects is this particular region. Can I have everyone please be on mute, please? I'm getting some echo. Okay. So this at most two subjects is leaving the students who have chosen all the three subjects in that particular college. So that is 400 minus 30, which is 370.
Sir, can I ask one doubt here? It is a complement of B intersection, M intersection C, at most two subjects.
Right. Correct. So it's just the complement of B intersection, M intersection C.
But here B intersection, M intersection C is the number of students who took three subjects, right?
All the three subjects.
But when it is told that at least two subjects, the student have taken three subjects, then why do we complement that?
I said at most two.
Oh, I thought you were talking at least.
No.
Oh,
I'm still in at most. Let me walk to at least. Okay, this is about at most. So complement statement for this at most two subjects is nothing but, so the same statement I can say it like this. Students who have not chosen all the three. Okay, I can say this at most two subjects. This at most two subjects is same as saying the number of students who have not chosen all the three subjects. So students who have not chosen all the three subjects, if I wanted to write in the set terminologies, so B intersection, M intersection C is the students who have chosen all the three. The complement will be the students who have not chosen all the three subjects. So actually we are trying to find this. Okay.
Got it.
Yeah. Now let's go to at least two subjects.
Sir, I just want to small clarity. When you say most two subjects and you're saying it's the complement of A intersection B intersection C, so it includes from the total universe of 400 minus that 30, right?
30, right.
Okay, thank you.
So this at least two subjects is basically students who have chosen two subjects.
More.
Or three, sir.
Or three subjects.
And three subjects.
Right. So when I have to show it in the Venn diagram, I have this. So this is biology, this is maths, and this is chemistry. So draw each of them separately. So two subjects. Students who choosing two subjects is this and this and this. This is about two subjects. Three subjects is again this light blue thing inside. So I have to find this red region plus red region, three red regions plus this blue region once, only once. So for that,
Yes,
I
sir.
will get, this is the region, right? This is the region for at least two subjects. Either the student is selected exactly two or either the student is selected exactly three. So to get this, what I have to do is B intersection M, B intersection C plus C intersection M minus 2 times of B intersection M intersection C. See, we are subtracting
Yeah, now I got
2
it.
times.
So now I understood.
Because if we are subtracting 3 times, this whole blue region is gone. But this time I should have that blue region also. That blue region is actually the students who have chosen all the 3 subjects. So I should have one blue region. But from this particular thing, we are getting 3 blue regions. So I will subtract 2 blue regions out.
Okay.
So finally, I will be left with 3 red regions with 1 blue region. One blue region.
One blue. Yes, sir.
So we have this as 200 minus 2 times of this is also 30 given to us. So 140.
40.
So this 140 is actually the students who have chosen at least 2 subjects. Okay. And 110 is the number of students who have chosen exactly 2 subjects.
Exactly 2, sir.
Yeah.
Understood.
And at most 2 subjects is 370. So this is the difference between at least, at most and exactly. So the term, if we change that particular name before the 2 subjects, whether it is at least or exactly or at most, answer changes.
Sir, so basic approach can be just to draw the Venn diagram and then start the question.
Right. Draw the Venn diagram, convert that whole data into this Venn diagram. Once you convert that Venn diagram, identify the region, what you have to find, and then compute that particular region cardinality.
For exactly 2 subjects, we have to take the B intersection M, B intersection C, M intersection C, and subtract the minus 3 times the value of that, or
Right.
2 times.
Right. 3 times.
3 times, no? Because we don't want that third part.
Yeah.
Blue part.
Right.
Yeah.
Sir. Okay, sir.
Okay.
Yeah. Sir, I have a question in question number 13, not the whole question, but only one thing I have a doubt on is that they ask the number of roots.
Can you read the question?
So before that, can I relate it to this question that we were just discussing? Can I ask one more thing that I want to clear? So here, if we want B union M, then we do not have enough data to calculate that.
Right.
Okay. Thank you, sir.
B union M, yeah.
Basically, we need na, sir,
because we wouldn't know the red area exact number. We know the sum of the 3
you are
areas.
asking about B union M, right?
Yes.
So that region is basically this particular thing. Right?
Okay. Right. So we can calculate. No.
Actually, this collectively, if we have questions on all the 3 red regions are including in that region. So you know the sum of all the 3 red regions. So then you can compute. If it is question like the students who have chosen only biology and mathematics, so then it would be difficult to compute. So if questions include computing each of the individual red region, then it is difficult.
So, but here also, sir, we need to subtract exactly the intersection part, and we don't know. So we need the number for the only one red region to calculate it.
Why we need? I don't get it. See, can we compute only C region? The students who have chosen only chemistry? Is that possible to
No,
compute?
sir.
It is given. No, sir.
No, sir.
It is
Yes.
given. Sir.
We can calculate that. C is given, and we can minus 110 and minus 30 from it. We'll get what is C.
But 110 also includes the third. But 110 also
C,
includes the third red area.
it is not
C minus B
Right.
union M will be only C, right?
C minus B union M will be only C.
But sir, chemistry students is given in course.
We can't compute.
No.
We can't compute, right?
We can't compute it. Let me. So if you wanted to find this thing, we need this thing.
B union.
This only C thing.
Only C.
Thing is basically
Yes,
B.
C minus
We have
C
to
minus B
subtract
union.
a whole from
B
union.
Union. Yeah.
Yes.
No, I think it's difficult, right?
The data is insufficient.
Yeah, data is
insufficient. Yes.
Thank you, sir.
We do it by subtracting C from A union B union C. No? We have A union B union C.
Yeah.
We can subtract C from that.
Okay, if you subtract C,
we cannot compute A union B.
This particular region will go on.
We will add then from total C from 200 true C. I'm talking about true C, not the intersections.
True C, we
200 minus 2 subjects minus 3 subjects.
So if you are saying only true C.
Exactly C. We will take out exactly C simply.
But we don't have, if we name the if we to simplify it, if we say just name them X, Y, Z, and maybe A. So intersection of all three sets is A, but we don't have individual values for the other three parts, X, Y, and Z.
Okay.
So you cannot, we don't know for sure out of those 110 how many are in each.
If you have exact value, then
yes.
Right. Okay.
So when we say exactly A or exactly B, it means true A and true B.
Right.
Okay, sir. Thank you, sir.
Sir, I have a doubt in question 9
Actually,
and 10.
the term is not exact.
Question number 3, option B.
Yes, sir.
Yeah,
question number 10.
Option B is incorrect. See, the idea is draw the polynomial. Try to draw or try to come up with the rough graph of that polynomial, how it is on XY plane. Then you can answer the questions. Okay, let me take.
This is question number 13.
Sir, but the graph we got and the answer we got are incorrect.
Right, correct.
Can you
The option is incorrect, right?
Option is incorrect.
Decreasing in
Okay,
minus 1 into 2 minus 2.
Decreasing.
The answer should be option 6, I guess. P of X is strictly decreasing.
Yes, sir.
When
Yes,
strictly.
sir.
I had the same
Strictly
problem,
decreasing.
sir.
Right.
Yes, strictly decreasing.
So whatever
Sir,
the graph.
can you please? Hello. Sir, can you please discuss the question number 2, option second? I didn't get this. How to solve that option?
Can you read out the question?
Just.
What is question number 13? Even question number 13, can you read out?
The question number 13.
Question 9 actually.
Okay.
Sir, roller coaster, question 9.
Okay.
Okay, sir. Question number 2, sir. Which of the following statement is correct?
I think it's intermediate value theorem question. Means there is no root if R is even, like that.
Right, sir. Sir, can you please explain the option 2? I didn't get that.
A polynomial defined on R with even degree.
May have no roots.
Yes, sir.
Yes.
It's
X
clear.
square plus 1 equals 0. Like so that it will have no
We can
real
assume
root.
parabola. We can
Yes.
assume parabola.
Yes,
Parabola may have 0 root.
If you have
root and two
complex
Irrational
root,
roots are possible.
we can say it has no roots, real roots.
Yes, odd functions always have roots because it will go through the axis.
I think that's intermediate value theorem.
No.
Please. Sir, I didn't get. Could you please explain it once again?
So polynomials having odd degree. So whenever I say polynomials having odd degree, you know the behavior of graph, right?
At least one root.
Sir, there's too much noise. Could you please like mute everyone?
Okay. So there are 4 cases in our polynomials. See, whenever in straight lines, we have only 2 cases. Either your slope is positive or your slope is negative. Depending upon the slope, you have lines like this. So if it is slope positive, it will be inclined like this. If the slope is negative, it will be inclined like this. Okay. When we come to quadratic equations, we have 2 cases. When either it is an upward parabola or downward parabola, either it is like this or like this, depending upon the coefficient of highest degree. So if the coefficient of highest degree is greater than 0, you will have an upward parabola. If it is less than 0, you will have a downward parabola. So in straight lines and parabolas, you are going to have only 2 cases. But when it comes to polynomials, you will have 4 cases, 4 different cases. So depending upon the coefficient greater than or equal to 0 or less than or equal to 0, as well as the degree being odd or even. So if your degree is odd and you have a positive coefficient, let's say a greater than 0, then your graph will be something like this. Whenever it goes to minus infinity, graph will be in the below x-axis, and when it comes to positive, it comes above x-axis. So I don't know what happens in between, but I know the end behavior of the graph. So when it is odd degree and coefficient is greater than 0, I will have this kind of graph. So I will start my graph below my x-axis somewhere. It comes between, something happens, and after some values of x, positive values of x, it goes to infinite. And when I have odd degree, okay, I will take it in this graph itself. When I have odd degree and a less than 0, I will have opposite of this. So it will be like this. Something happens in between, and it will go like this.
Sir, about that, can we say it is strictly decreasing until it touches x-axis?
Right. So until meeting the first root, it will be strictly decreasing.
Yes, if the domain interval is open, right?
Okay. Right. So until it touches the first left side of the root, it will be strictly decreasing, and after that also it will be strictly decreasing. After the last root, it will be strictly decreasing. Okay.
But we cannot consider the root, right? Because at the root, the slope is 0 and it is not strictly decreasing, right?
At the root, you can't say the slope is 0.
Matlab strictly decreasing, right?
See, even after that, you don't know, depending upon the multiplicity, it bounces back or
yes,
it goes inside.
Yes. If the multiplicity is 2, we cannot say it's strictly decreasing, right?
Yeah, right. So that is other story. So what I am talking about is that end behaviors. How the graph behaves when x is tending to minus infinite or x is tending to plus infinite. So
how can you explain this for even degree also?
Yeah, I will.
A greater than 0.
So
Thank
odd
you.
degree will be like this. Okay, it will start from positive side of x-axis, and after some time something happens in between, depending upon the roots, multiplicities, and everything jumps downs. After that, everything happened. After the last root, it will go like this. If this is odd degree and a is less
A
than
is negative.
Yeah. If it is greater, the story is opposite story. So this blue story, like this and like this. But where it comes, see, from this graph itself, you can identify that if my polynomial is a odd degree, it should definitely cross x-axis once, at least once, because my graph is starting above x-axis and after some time it is coming below x-axis. So that means at one point, or at least at one point, Actually, it should cross x-axis because it is smooth curve. So whatever the polynomials we are discussing here, they are smooth curves. So it should not break in between. So that means starting from top, coming to bottom, definitely it should cross this x-axis. So from there I can say that at least if my polynomial is an odd degree, definitely I can say that at least one root is fixed. At least one root is fixed.
So that
Sir, I
a
have a
greater than
doubt.
0 is strictly decreasing or is it increasing, sir, towards
What?
2?
Which one?
A greater than 0, is it increasing or is it decreasing, sir?
For a
Towards
greater than 0, it's actually increasing. It is increasing till here. Something happens in between. Again, finally it will increase.
Okay, so it's completely opposite.
Yeah, for a less than 0, it will be decreasing.
So if in the interval, if the root is included, like if it is given minus infinity to minus 2 and minus 2 is included, then what will we say? I mean, it will be decreasing up to minus 2 and at minus 2 the function will be 0, right?
So see, decreasing and increasing doesn't take with function values. It will take with
domain
function
values.
It doesn't take with becoming 0 or not.
Yes, sir.
Will be decreasing. Excuse me, sir. Sir, can you please discuss the question number 7 from the graded assignment?
One second,
four?
sir. 1 second. The increasing part in the graph of end behavior, the below one, it is going towards minus infinity, right?
This one.
The blue one, yeah. So it is increasing only, right? It is increasing down, and the upper it is increasing plus infinity.
It is
both sides.
No. Yeah, this is increasing. I said this is increasing only. When did I said this is
Sentence
decreasing?
is reversed. That means it decreasing. It depends on how sentence is framed or
Yeah. Again, it
option
depends on how
is
sentence
given.
is. Generally, we will talk about when x is increasing, what is happening to y value.
Yeah.
So that is what we see. So when x is taking larger and larger values, my y also takes larger and larger values. Okay, so it is increasing.
Okay, now.
Excuse me,
But
sir.
I'm looking the other way, sir. When x is going toward minus, y also goes towards minus infinity, right?
So it is decreasing.
It is decreasing, right? So see, when x is decreasing, y is decreasing. So when you say when I am going to minus infinite, are my values of x decreasing or increasing?
Yeah. When I go minus infinity in x, my y is going minus infinity only.
Your y is going minus infinity only.
Yeah. So decreasing.
Why? I didn't understand. Why?
minus 2 based on the
Sir, my x-axis going towards minus infinity.
Okay.
Then
so is your x decreasing or increasing there?
No, x is straight. It is towards minus only. It is having minus 1, minus 2, minus 3, something like that.
Right. Minus 1, minus 2, minus 3, minus 5, minus 10, minus 100. Is your x keeps on decreasing or?
Oh, decreasing.
Yes, it's with the minus sign.
Decreasing.
And y is also decreasing.
Y is also decreasing, right?
Okay. I got it.
When your x is decreasing, if your y is decreasing, that is increasing function.
Okay, got it. Okay, I just took the plain. Okay, yeah.
Yes.
I got it. Yeah, thanks.
Sir, if you consider the green line, like on the left side.
One second, one by one, please.
Sir, please consider question number 2, sir. Then it will be clear all doubts, sir. Question number 3, sir.
Yeah, question number 3, I will take it.
Yes, 1 second on this. I have
What will happen for even degree? Can you please explain?
I will go. See, once I am done with odd degree, if students are convinced, then I will move to even degree. If students are not
on
even
this,
convinced,
I have one doubt.
Yeah. What is?
Sir, can you please take example of x cube plus 5?
Just 1 second.
Yeah.
Please. So what he asked, move from 0 to minus infinity. Now he asked. So when we are moving from 0 to minus infinity, just now you were explaining.
Yes.
When we are moving 0 to minus infinity, our x value is decreasing.
Yeah.
Our y value is increasing, na?
Y value
0 to minus infinity.
0 to minus infinity is decreasing, right?
Yeah.
If a is
0 to
greater than
minus
0.
infinity, x is decreasing.
Even y is See, y going 0 means y is taking here. Y is
That's about this one. Okay, blue one. I'm thinking about the green one. Sorry.
no. We are
Green
talking
is
about blue one.
A is lesser than 0.
Okay.
See,
Okay, fine, thank you.
don't treat it as looking at the graph. I am moving from this to there or from top to bottom. It's not. It is not how decreasing and increasing works. Look at, you increase your value x, slowly increase your value x in that particular region. See how your f of x or y is changing. If your f of
So
x
it's
is
depend
also
on the interval. If they will give minus infinity to minus 2 or minus 2 to minus infinity, both are different. No?
Yes, that was my query also. If we have
Same
minus
question,
2 to
sir. I do
minus
have the same question. The order matters,
Yeah.
like minus infinity to minus 2
Yeah.
or minus
Sir has already explained.
okay. I will just tell you. Interval will not be like this. There is no interval like this. This is an blunder in mathematics. Okay, so how we write is, usually the intervals will be whatever the interval
Decreasing.
interval will
Increasing.
always be smaller to bigger. So when I say
Okay.
this is the interval AB, I should write AB as like this. That means x is taking values from A to B. My A is smaller than B. Okay, this is
Yes,
how
sir, yes.
intervals are usually defined, generally defined. Or you can mathematically say this is how we define intervals.
And
So it
now
will be
clear.
always from
Sir,
minus infinity only.
Yeah, intervals are always defined from smaller value to bigger value.
Or minus 2 to 5, like that we can say.
Yeah, same thing. So
but
whenever
why, sir,
A
minus
to B is
2?
an interval, my A is smaller than B. A should be smaller than B.
Okay.
So I wanted to clarify something. Just now you said that when x is decreasing and y is decreasing, it means that the function is increasing.
Increasing.
How is that?
Okay, take an example.
So when both are decreasing, then the function is increasing.
See here itself. This is increasing or decreasing?
So
Increasing.
Is this function
Increasing.
Decreasing.
Okay, I start from here. My x value starts from here. I will keep on moving to the left side. Is my x values decreasing or increasing?
Decreasing.
Decreasing. What is happening to my y values?
Decreasing.
It is also decreasing.
Decreasing.
Okay. So when your x decreases, if your y also decreases, then the graph is an increasing graph.
Sir, so we have to go left from no, sir.
No, sir. Why only left? If you do the opposite.
I think when both moves in the same direction, increase or decrease, then it will be the increasing function. When they are moving in opposite direction, one increases, other decreases, then it will be the decreasing function.
But sir, why did we only choose this particular point from which we go left?
You can choose any point, not even this point.
And sir, why left?
Interval.
Why only towards the origin? If we go to
See, you can go from here to minus infinite also.
Okay, sir.
But if you go from origin to towards x-axis, right side.
Origin to towards x-axis. Okay, my x is increasing here.
Huh.
So is my y. So my y value is here, but after some time my y value is increased.
Look at the y-axis, how y is moving.
So the function is decreasing. Yeah. Okay.
Increasing.
Increasing.
If x is increasing, y is also increasing.
See, simple.
Increasing.
See, it means
Look
it
at
is
the y-axis and judge.
Yeah. If x is increasing, y is increasing, same as saying x is decreasing, y is decreasing. Both statements are same. If I say when I increase x, my y is increasing, it is same as saying when I decrease x, my y will decrease. My f of x will decrease.
Okay.
Same thing. Okay. Going
So in the above figure, what will be the graph of in fourth quadrant, the green one? It's decreasing or increasing?
It is decreasing.
It is decreasing. So when I see, simple, either you take x is increasing, or either you move on one side, either you move right side of x-axis or you move left side of x-axis. Both are same. So once you are increasing your x values, if your function value is increasing, so just take two values, it is sufficient. Just take
So in
two.
this case, y is decreasing, right? So when x increases and y decreases, what will be the type of function?
Decreasing. See, just take two different values. Let's say 10 and 20. So look at f of 10 and f of 20. Okay, if f of 10 is greater than f of 20, then the graph is decreasing. If f of 10 is less than f of 20, then the graph is increasing. Okay.
So we have to
what will
take two
happen if
values.
we reverse the direction? On reversing the direction, what would happen, sir?
Same thing happens. See,
This graph
reversing.
you can find out easily.
See, 10 less than, you are saying that 10 less than 20 is same as writing 20 greater than 10.
Yes.
Yeah, that is the same thing, sir. I want to ask, like minus infinity to minus 2 and minus 2 to minus infinity. They are two different directions, right?
Just now I said that there is no minus 2 to minus infinity.
Okay, that is the blunder. So we only
excuse
consider. Which direction do we need to consider right now, sir? From the lower to the higher end?
Usually follow this trend. Look at when x is increasing, what is happening to y. So even if your y increases or your function increases, function value increases, it is an increasing function. If it is decreases, it is a decreasing function.
Excuse
So
me, sir.
maybe the y value depends.
I use
Why-
a different analogy actually. What I did means when I plotted the graph, I started from the top end. So I thought that it is positive infinity. When x is going negative, then it is going means we are going from up to down. That's why it decreasing. So is the analogy correct?
This one.
Yeah.
This is
We are
decreasing.
going down, so function will decrease.
But always question will ask in between some interval.
Yeah.
So in
We have to check for the interval, I guess.
you see, whatever the interval is asked, take 2 points in that particular interval. One
Okay.
smaller point and one bigger value for x. Check for function value for smaller one and the bigger one. If you have the same symbol, like I take a, b, a is less than b. If you have f of a is less than f of b, then treat it as, then it is increasing. Okay, but if you are having f of a is greater than f of b, it is decreasing. Opposite sign, if you are getting an opposite sign, then it is decreasing. If you are getting the same trend means when x is increasing, if your function value is increasing, it is increasing function.
Okay, sir.
Okay.
So means this analogy is same for odd and even functions.
Odd and even functions.
Odd and even functions are different. So
Yeah,
if
whatever this is all.
Sir,
Odd
if
degree and even degree you are talking.
Excuse me, sir. Sir, am I audible?
Yeah,
Actually,
you are
because
No, odd function, even function also
Yeah,
there
sir.
in the syllabus.
I was actually asking about odd and even function only. Actually, I saw some questions regarding that. That's
Sir,
See,
One
odd and
question
even
was there,
functions will
odd
come in-
function,
Yeah.
even function. Yes, we have. In practice assignment, one question is there. Whether the given polynomial, higher degree polynomial is even function or odd function. Like two questions are there. Graph is given and he was asking whether it is even function or odd function.
I was not able to get that. Means what do we mean by odd
Okay,
and even function?
Yes, sir.
don't
Can
worry
you
about
please
that.
explain even and odd?
sir, I have a doubt in this question only.
You have put in?
Sir, I have doubt in this question only, question number 3.
I will come to you. I will come to you. So before that, odd function and even function comes in detailed in week 5. Don't worry about that one particular question. It may have misplaced. Okay. So as of now, don't worry about what is odd function and what is even function. We will discuss that in week 5.
I think in the question
sir.
in the note it was already mentioned that if f of minus x is minus fx, then it is like it is odd, and if f of minus x is fx, then it's even. So in the note it was already mentioned, I think so.
Okay, note it is mentioned. But we will study in detail. Don't worry about the odd function and even function, and don't get confused or don't spend much time on that thing. So that is not in our 1 to 4 week syllabus.
Yes, sir. Yes, sir.
Maybe
Move
one
on.
question might have misplaced. We will rectify it. And week 5, we will discuss it in detail. Yeah, Kalrav, you have some.
Yes, sir.
Yeah.
Sir, so in question 3, P of X is decreasing from minus infinity to 2, right?
Graded assignment.
Yes. Yes.
No, the mock test quizzes.
Yeah. In mock test.
So that question is wrong, right?
Yeah, that question. See, I have said it.
Question is correct. The answer is wrong.
Yes. Yes. Sorry. The question is correct. The answer is wrong.
Yeah.
Okay.
Right. So this is
So
about
the
question
parabola
number
is wrong.
9
One question
and 10.
here. Can you please explain?
which one?
Here only.
Ah.
In higher degree polynomials, can we say about the whole function will increase or decrease?
No.
No, it's not possible.
Without plotting the whole graph, we cannot say in the whole region it is decreasing.
We plot a higher degree polynomial of 9 or 10, and we got several multiplicities 1, 2, 3.
Okay. I will take that as an example and I will explain it detailed. Just give me, let me explain this even degree also. So
Sure.
we have seen this odd degree.
I have doubt in the odd degree, but
Sir, I have a doubt in question number 3, sir.
let an example x cube plus 5 is equal is a polynomial. So how can we draw the graph here, and what are the roots of x cube plus 5?
Something like this.
How we find the roots?
It's actually x cube plus 5 is 0. X cube is minus 5. X is cube root minus 5.
In this is also not a real root.
This is a real root.
Root under minus 5, I think it's a complex.
It's a cube root.
No, see,
It's a cube root.
This is cube root. This is not square root. Square root under negative is not allowed. Cube root under negative is allowed.
Yeah.
So this is actually minus cube root 5.
Okay. Is it a element of the real number?
Right, of course. So this is actually x is minus cube root 5.
Okay, so I don't get that number. So how to calculate that?
Okay. See, actually this is cube root, right? Cube root minus 5 you got. So how I will write it as minus 1 to the cube times 5. So minus 1 to the cube, I can bring it outside. Minus 1 of cube root 5.
Okay. So that was my little concern. I thought that so it's a complex number, so it will also have the.
Definitely. So as I said now, right? If it is a cube odd degree polynomial, it has some behavior, and behaviors will be something like if it is a greater than 0 and odd.
Right. Means it will always intersect the x-axis.
Always.
That
because
is what
see, it starts from minus and it should go to plus. Somewhere it should in between. Somewhere it should cross.
Okay.
Right? See, you
So,
are in
that number is confusing for me. That's why I choose the wrong answer.
No. Okay.
In the mock test.
Now correct yourself. See, this is one house and this is another house. So you have to reach from this house to that house, and the only possible way is going through this. So definitely you should cross that pillar or some wall. Definitely at some place. Either you can jump it here or here, wherever. But it should cut it.
Okay.
Hello, can we discuss question 4 and 12?
Sir, tell me about which area positive or negative in the graph. It's a little bit confused me.
I will take that question number 3 now. Let me complete this.
And when it comes to the equal roots, will we count as only one root? Multiplicity with 3 or 4 or 5?
Right. So one root with
Only
multiplicity
one
2 or 3 or 4, depending upon the multiplicity.
It's only one root.
It is one root.
Okay.
See, that depends on wording. So x power 9 is equals to 0 has 9 roots. Okay. X power 9 is equals to 0 has 9 roots, but all the roots are 0.
Yes, sir. Yes, sir.
That's it. So depending upon the convention we use, usually we tell x is equals to 0 is the root with multiplicity 9.
Yes.
Or we say
X
there are
minus 2, x minus 2 whole square equals to 0.
Okay, even here also x is having 2 roots because this is quadratic equation.
Plus minus.
Okay.
Mm.
Quadratic equation with roots 2 comma 2. So it will have 2 roots with 2 comma 2. Or I can say x is having root at 2 with multiplicity 2.
And this is what
Sir,
counting
are
the
you
roots a
speaking
little
or
bit
someone else
confusing.
is speaking? I don't know.
I'm the one who is speaking. So counting the roots, see you when we ask like find the number of roots, you should.
Srikant, are you talking?
Yes, he's talking now.
Please mute.
I should go to mute, huh? So who will?
He is only talking.
He's the instructor, Gunendu.
Sir, he is a teacher.
Who else is gonna instruct then?
Yeah, please explain equal roots and counting roots.
Yeah,
please.
counting roots. As of now in our course, okay. So, as of now, what we say is x is equals to 2 is the only root. Okay.
Sir.
So that is our convention.
One root.
Our
Counting the
convention
roots.
is, yeah,
Counting roots is tricky. Counting.
One root. We say one root.
Okay.
Yes, sir. Question 13 is.
That is our convention. Okay, that is only our convention. So you can come
As
up with
of
some
now.
other textbook saying there are 2 roots. I can agree
It's
with
okay.
that
Let's
also.
leave that.
Yeah.
If it comes in the exam, that's what I'm asking you. Do I count it as a one or
Single.
two single?
No, single.
Thank you.
See, when it is even polynomial and a is greater than 0, it will be like this. Okay. Some upper quotes kind of thing. So even when x is minus infinite, my graph will be positive side. That means it is decreasing here and it will increase here. Something happens in between, just ignore that part. But end behavior, when my polynomial is even and if my leading coefficient is greater than 0, then I will have an upper quotation kind of thing. Okay. So this single quotes kind of thing. So this is how you should remember. If a is less than 0, it will be inverted like this.
Sir, I have some a small doubt, sir.
Hmm.
From the polynomial, how to know a greater than 0, a less than 0?
Leading coefficient. See, if you have the polynomial with you, find the degree find the leading degree. So which is something once you multiply, or if you have something like this of form a x power n plus b x power n minus 1. Like this, if you have, find this leading variable x power n and look at the coefficient of that. Look at the coefficient of that particular thing. If it is positive or negative, that is what we are concerned about. We don't need to worry about the value also. Okay. When a polynomial is given, find the leading coefficient. Leading coefficient means the x which has the highest power to it. Okay. So that coefficient, find the coefficient of that particular term, and depending
Okay, sir,
upon.
got it, sir.
Sir, I have a doubt in question 4.
I will.
So sir, in this case of this even degree, it may be possible that there is root or not, because if it won't touch the x-axis, there won't be any root.
Bad daddy.
So see, now if this particular thing goes like this.
Mute, sir. Mute everyone.
Okay. So as we have seen, the nature of this even, both are upward and both are downward. Sometimes it may happen like these two have crossed like this. Or the thing is, you are in this house, you have to go inside one of the room. You don't need to cross this wall. Okay, you should be in that particular region itself. So I can go like this, or I can go like this. I no need to cross this, no need of crossing this. I can have various polynomials. If my polynomial have even degree, and even whether it is a greater than 0 or leading coefficient greater than 0 or less than 0, I don't worry. But I can come up with the graphs such that it may not even touch the x-axis. Okay, so that is
Yes.
why a graph, a polynomial with even degree may not have roots, but a polynomial with odd degree, definitely it should have one root. And these are the end natures of this. So these are the four different cases, depending upon whether we have odd degree or whether we have whether my leading coefficient greater than 0 or less than 0. So four different cases, four different graphs, different kinds of graphs. Okay, let us take that question number 3, and we will discuss a lot about that.
Yes, sir. I have a doubt in option number first, sir.
First one.
Yes, sir.
What was that?
Sir, consider a polynomial. I have a polynomial, sir, and we have to draw a graph, and where we have to point that exactly the number of point where tangent can be 0.
So that is question number 3, right?
Yes, sir. Yes, sir. Question number 3, option number 1. Sir.
Okay, that is what. See, we have this polynomial with us. Now, p of x is given as -1 times x minus 1, x minus 2, x minus 3, x minus 4, x,
sir, minus 3 to the whole square. Sir.
X minus
3 to the whole
3
square.
to the whole square, right? X plus 1, x plus 2 whole square. Okay.
Yes, sir.
So this is the polynomial we have. From this polynomial, just get the degree of it first. So first and foremost thing is draw the end graph first. So what is the degree of this polynomial?
9, sir.
9, sir.
So that means odd degree, right?
Yes, sir.
And also, what is the coefficient of this?
So negative
coefficient of
coefficient.
leading?
Negative.
Negative, right?
It
So
will be
so highest degree highest degree term you will get by multiplying this,
Yes, sir.
this and this. You will get x power 9th term, which has coefficient -1.
Yes, sir.
So my leading coefficient is a less than 0. Now we have seen when a is less than 0 and odd degree.
Second and fourth quadrant, sir.
So once you have this directly, you know the roots. Just plot those roots. -2, -1. You have 0, 1, 2, 3, 4. Right? These are the roots we have.
Yes, sir.
Now see below this -2, or just now we have discussed, until we meet the first root, when a is less than 0, and if it is an odd degree, we will
Yes,
have
sir.
something like this, right?
Yes, sir. Got it, sir.
Now after 4 you draw it. After 4, once it is like this, after 4 it will be like this, because it is
Towards
odd
the
degree.
y-axis. Yes, sir.
Once you are done with this, so for each and everything, just look at the multiplicity of this root. Depending upon the multiplicity, we will decide whether to go down or whether to bounce back. If it is an even multiplicity, you should bounce back. If it is an odd multiplicity, you should cross it.
Yes, sir.
Okay?
Yes, sir.
Okay. So at -2, you can see at -2, it has an even multiplicity.
Yes, sir.
Right? Even multiplicity means it should bounce back. That means it should bounce back. And I have to reach this -1 because I have a root at this point.
Okay.
Yes. I shouldn't go like this.
Yes, sir.
So once I go like, I cannot reach -1, this particular point. So once I should reach that -1 point, so I will come back somewhere. I will take a turn and I will come back to -1. Now
Yes,
after reaching -1, what I will do is I will look at the multiplicity of -1.
yes, sir. Even odd, sir, odd.
Odd multi is 1. It has
One.
power 1. So it is odd multiplicity. So I should cross it. I should cross that point.
Yes, sir.
I will cross it. And again I should reach to 0. I will come back to 0. And I will look at the multiplicity of x. As it is again an odd multiplicity, I
Yes,
will
sir.
cut it. And again I should reach 1. Once reaching 1, you see even 1 has odd multiplicity. I should cut
Yes,
it.
sir. And 2 also.
Again I should reach 2.
Yes, sir.
When I see 2, even 2 also have an odd multiplicity. So I will cut it here also. I should reach 3 again. So once I reach 3,
Yes, sir.
Will bounce back.
Bounce back. Because see, 3 has even multiplicity. So it should bounce back.
Yes,
And
sir.
it should reach 4. And it goes like this.
Yes, sir.
Okay. This is how we will plot a polynomial if the polynomial is given like this.
Yes, sir. Got it, sir.
Okay.
Hello, sir.
So
Sir,
now
can you please
Can I please
how a is less than 0? After degree 9, can you please explain, sir?
See, a is less than 0. You will get it from multiply this particular term with this particular term with this particular this, and this. So this is the highest term, highest degree term you will get. Right? In between, if you multiply it with some of the constant, you won't get the highest power with you. So in order to get the highest power, you should multiply x with x. So when you know the degree, you will know that x power 9 is a term inside my inside this polynomial. X power 9, there is a term x power 9, and that is the highest term I have. That is why I fixed degree as 9, right? How I got 9, degree as 9?
Like all the powers of the terms is given.
All the powers mean
just add all the powers.
Just add all
Adding
the powers.
of yes, sir.
Sir,
Sir, option number 1, sir.
sir, how can we decide the graph started from second quadrant? Why not in third?
See, that
Sir,
is
how
what
decide a is less than 0?
That's why.
See,
Sir,
I have spent half an hour time to just discuss this odd degree and a less than 0 case, and you are again asking me.
No, sir.
Am I not clear or?
Clear, sir.
A यहाँ पे है a minus
Sir,
minus.
I have one question here, sir. Just up the slide in this polynomial. Here, one point is x and parenthesis open x plus 1. When I multiply this x with x plus 1, the total degree will be 10.
Why?
Ouch.
It's x square plus x. Then we add 2
okay, see.
plus 2 plus 1.
See, okay, this is x square minus 6x plus.
No. This is not I'm saying that. This term is will be as it is same here x, then parenthesis will open x plus 1.
Which
after
one?
x minus 4. After x minus 4.
Here.
Here. If we multiply this, then x square plus x.
Okay.
Then we add this all degree. Then 2 plus 2, 4 plus 5. Then total degree will be, I think.
Why are you multiplying this and adding? I didn't get this point.
First, you have to do, sir.
This is actually, don't worry. This is actually a polynomial. We have given you a polynomial with roots.
Yeah.
-2, -1, 0, 1, 2, 3, 4 with some multiplicities where at
Srikanth, actually, he wants to know what is the polynomial. So that's why he is multiplying everything to get the polynomial.
No. He's just multiplying
Standard form.
These two terms, and he's
then adding the then adding all this degree of highest term.
No. You shouldn't do like that. You should simplify your terms first. These are the factors of this polynomial. Okay. This x plus 1, x plus 2 whole square, x minus 4, x minus 3 whole square. These are the factors of p of x.
Okay.
Okay.
Point of
Yeah, x square plus x is actually I can split it into two factors again, x into x
Again,
plus
yes.
1 kind of thing. Okay. This
Okay.
is not a.
That will be same things. Yes, sir.
Actually, okay, sir.
When you want the polynomial, actual polynomial, if you wanted to find the actual polynomial, just multiply all the terms. You will get something like x power 9 minus some term x power 8 plus something x power 7 and so on, something, some constant, like this kind of thing, general kind of thing. Okay. Yeah, once you get that, you will see that the coefficient of this x power 9 is -1, because this -1 will be multiplied to it, and that particular -1 is nothing but our leading coefficient.
Yes.
Which is
Yes, sir.
that leading coefficient is negative. -1 is negative, right? Negative means it is less than 0. So that is how we
Okay.
conclude that a is less than 0.
Okay, sir.
So as he said, will we get this kind of factors, x square plus x there? It won't come, right?
So for this question, option number 1 is there are exactly 8 point on a px where the slope of the tangent can be 0. Can you explain this point?
Yeah. See, now I am going to that option itself. So
Yes.
once you got this graph,
okay,
so slope becoming 0, slope of some tangent is 0, means that tangent is parallel to x-axis, right?
Yes, sir.
Right?
Yes, sir.
Slope of that particular tangent becoming 0 means, so which all the lines will have slope 0?
Sir, all the vertices.
All the
vertices.
Vertices.
Turning points.
Don't say vertices.
Turning points.
Vertex
Turning
is only
points.
for
Yeah,
parabola.
basically turning points. Yes.
Yeah.
Turning
So when
points.
you,
Point where the slope will be 0.
yeah,
Yes.
when you consider these particular points,
Yes, sir.
this wherever the turning point is there, turning points are actually points where the nature of the graph changes. So these
Yes.
are the turning points.
If you draw a horizontal line at the turning point, it's strictly horizontal to the x-axis.
Yeah. So when I compute the tangent at this particular point, I will get like this, something parallel to x-axis.
Next axis.
Parallel to x-axis means that particular line has slope 0. Okay. So we
Yes.
asked you how many number of such points are there such that the slope at that particular point, slope of the tangent at that particular point is 0. So simply you have to find how many such these points are there, how many
There.
such turning points are there. So when you
Yes.
compute, this is one, this is another, this is one more, this is another, this one,
Total 7.
this one, this one, this one. 1,
Yes,
2,
6.
3, 4,
4,
5,
5.
Become 8, sir.
7, 8.
Okay.
1, 2, 3, 4, 5, 6, 7, 8.
But here point 3 and we will count this also, point 3 and minus point 2.
Of course. See, wherever
Sir,
the graph changes, if the graph is decreasing and suddenly it changed to increasing, then that particular sudden point is the turning point. And the
Okay.
same thing goes with when the graph is increasing, suddenly if it changes to decreasing, even that point is also called as a turning point.
sir,
The
why we
nature
not
of the graph
count
changes. Huh?
0 and sir, why we not count 0 and like roots of that polynomial?
See, why we not considered is, see, at 0, the graph is increasing before 0, and after 0 also the graph is still increasing. It doesn't change the nature of the graph.
Sir, but at 8.0, so it will be 0, no, sir?
At point 0, the slope is 0. Who said this?
Me, sir.
No. Who said means any mathematician or something.
Actually,
So is there any statement in your lectures or somewhere saying that at roots,
Sir,
the slope of the tangent is 0? Such kind of statements?
no,
Is
sir,
any?
but can we consider like a point?
No. See, this particular point will not have, if I draw a tangent at this particular point, it will be something like this, something
Yes.
like this.
Okay, sir.
And this particular tangent will not have slope 0. It will
Yes,
have something If it is alpha, it will have some tan alpha slope, which is not 0. Okay.
Sir, in the interval of -infinity to -2, it is increasing or decreasing?
Decreasing.
Sir, one more thing here. If I
Sir,
say
sir.
roots and 0 are the same term, can I use same as?
Right. Zeros of a polynomial is same as roots of a polynomial.
Okay, sir.
Yeah.
Excuse me, sir.
Mm.
Sir, I have one doubt. In lecture that in a cubic graph means sir said at that means when it crosses that x-axis, there also it changes that nature, no? But sir said we cannot consider, we don't consider it as turning point as of now. He said.
This one.
Yes. Sir.
See, even here it's here also. Just see, I explained this increasing, decreasing, right? What
Yes,
happens when I start from here? I take this value and this value, -2 and -1.
Yes.
So -2 is less than -1, right?
Yes.
So what is -2 cube and -1 cube? What is the sign of? What is the relation between -2 cube and -1 cube? This is -8. This is -1.
Yes.
Right? Is this less or greater?
-8 is less than -1.
Less than, yeah. So when my x, when I take two values of x, which is one smaller and one bigger, my f of x, so I say x1 and x2. Even my f of x1 is less than f of x2, right?
Yes.
So when I take two values, one is lesser than the other, the same behavior or the same thing is happening to my f of x also. So that means I said this is an increasing function.
Yes.
So in this interval, it is an increasing function. From the graph itself, you can see when I'm moving right to x-axis, I'm moving upwards.
Sir, my doubt is not increasing.
Okay, I will tell.
Yes, sir.
If this particular point 0 to be a turning point,
yes.
Before that point, this is an increasing, but after that point, it should be decreasing if this point to be a turning point. Okay.
Yes, sir.
That is the definition of a turning point. Nature of the graph should change, either increasing to decreasing or decreasing to increasing.
Yes,
so till here it is increasing, and after this 0 point, if 0 to be a turning point, the graph should actually decrease. But instead, what is happening here?
Increasing.
It is still increasing. Before that,
yes,
it is increasing, and after that also it is increasing.
So that's not turn.
So that is why it is not a turning point.
So
in order to be a turning point, either it should increase to decrease or decrease to increase at that particular point.
So as of now, we don't consider it.
No, as of now not. In future also we don't consider.
Yes, sir. Another one doubt means how can we conclude that 1 or 1 2 because while by seeing graph that is I'm not able to.
By seeing graph,
means
okay.
By seeing graph, how we can conclude 1 or 1.
Even this we will discuss in week 5. So the guys who have gone through week 5 contents might have known this vertical line test and horizontal line test.
Yes, sir. Yes, sir.
We'll discuss.
So what is given in the mock test only?
Week 5. So as of now, what you have to remember is a function is basically a relation. Okay, from relation there is a function, and if we ask you 1 1 and on to about that particular things, what you have to simply do is just try to find one input. If your one input is mapping to one particular output, then that is I will discuss that one also. Okay. Once I am done with this, I will come to that one.
So just to let you know, in Solve with Instructor conducted on Saturday, the entire graphing thing along with 1-to-1, is it 1-to-1 or not? It was all discussed.
Okay,
yes. In and was very well explained.
Okay, fine then.
Hello, sir.
Go back to that.
Sir, I have a question. How can we conclude the degree of any polynomial by looking the graph and the turning points?
We can conclude, bro. Please, some attention.
Okay, how can you conclude? I cannot
Right,
conclude exactly, but I can sort of quickly go nearer to that conclusions, very nearer to that conclusion. Okay. Basically, see, this particular thing.
Those who missed previous session should have watched the previous session, sir.
Yeah. So this particular thing, graph can be either x square or x power 4 or x power 6 or x power 10 or x power 1000.
Right,
Okay.
sir.
So until I have a further information about this, I cannot actually comment on this. But one thing I can comment is, as it has one turning point, the degree should be at least 2. That thing I can conclude.
So we should only consider at least degree of the.
Yeah, at least can
polynomial.
be told, but not exactly.
Okay.
So if you have some n turning points, n plus 1 degree, at least it should have n plus 1 degree. Okay, 1 greater than the number of turning points. Okay. So,
okay.
Yeah,
So,
this particular thing is, yeah.
Sir, in this graph, from 2 to 3, why is it going from up and not down?
2 to 3, why it is going up? Because at 2, see, it has multiplicity 1.
So, sir, it should be down, right?
Odd multiplicity, right? Odd multiplicity, it should cross at that particular root.
Oh, so I'm not clear with the multiplicity concept.
See, multiplicities are nothing but how many times the root is being repeated in your polynomial. Okay. So here you see x minus 3 whole square means here this polynomial has a root at 3 with multiplicity 2. That means there are 2 roots we are going to get out of the whole 9 roots. We are going to get 2 roots which are 3 actually, 3 comma 3 kind of thing.
Yes, sir.
Okay. That means in order, if instead of writing 3 comma 3, what we write is 3 with multiplicity 2.
Okay.
Okay. With multiplicity 2 tells me that 3 is repeated twice.
Okay, so
If
then
this,
how do you translate it to the graph?
how this play a role in graph is, if your multiplicity is odd, if your root has multiplicity odd, at that particular root, the graph actually should cut and go to the other side.
Okay.
Like this 0, 1, minus 1, 2.
Okay, sir.
All these have odd multiplicities, which are 1.
So then even it has to stay on the same side.
Even it is actually bounce back, or it should stay on the same side. Stay on the same side. And if it is,
Sir, can we discuss question 13 and 14 from the mock test?
So,
Yes, sir. Please discuss.
So this is about
sir,
option.
first can
Sir, question 9 also roller coaster.
Sir, first question 4. That's the next
Sir,
question. So I think
question 13 and
The roller
14.
coaster one, please.
Excuse me, everyone.
Wait.
So you could take on the questions one by one and discuss the answers, and then after discussing all the answers, you could take up one
yes,
doubt.
exactly. So
Yeah,
after question
yeah.
third,
Just
that
save the
question
time of
4
the
must be the
question.
question.
So
Yeah,
the
okay.
thing
Sir,
is,
because all this have been discussed earlier.
Okay.
So
after this session, you are going to get the solutions of your mock. Okay, detailed solution. So don't worry, just go with me and also go with the mock solution. If you didn't understand, then come back and look at this lecture. Or okay. So once option 1 is like you should find this number of turning points. So just count the number of turning points. Those are the points where the slope of the tangent is actually 0. In the option 2 or option 6, both are contradictory options. Once you solve one option, if that is correct, the other one is wrong, or if that is wrong, the other one is correct. So what it says is p of x is strictly increasing when x belongs to minus infinity to minus 2. Now my x is only this. So I am worried about in this interval only. What is happening to my graph in this particular interval? Whether it is increasing or decreasing. So is it increasing or decreasing?
Decreasing, sir.
Decreasing, sir. Decreasing.
Right. So take two values, find the function values at these two. If it follows the same trend, it is increasing. If it is not following the same trend, it is decreasing. Here it won't follow the same trend. Your smaller value of x will take larger value of y, and your larger value of x takes smaller value of y. So therefore it is a decreasing. So what we say is option 2 is incorrect, option 6 is correct directly without even computing again for option 6. What we do is directly we will mark option 2 as incorrect and option 6 as correct. Okay.
Yes.
And option 3 is p of x is 1 to 1 function when x belongs to minus infinity to minus 2 union 4 to infinity.
Yes, sir.
Now see, now we are concerned about this region as well as this region. So that is the region where minus infinity to minus 2. Is this color visible? I don't think so. Minus infinity to minus 2 is this region. Union 4 to infinite is this region. Right? Now what it says is this particular function is a 1 to 1. Is this particular region? So now the graph has shrunk. We don't have this graph in between. We have this graph and this graph. So the end graph we have. So is this 1 to 1?
Yes, sir.
So looking at the graph, how we check 1 to 1 is basically, see, when you draw a straight line parallel to x-axis at any place, it should only intersect at one particular point of the graph. So when I draw any straight lines anywhere in this region, my graph is being intersected only once. So I can conclude that it is a 1 to 1 function. Now, in order to understand this better, if you see in this particular region 2 to 3, if I draw a straight line like this particular straight line is intersecting this particular graph 2 times. That means my input, if my x is something this and if my x is this, for 2 different inputs x1 x2, I am going to get the same output value, same output. F of x1 is same as f of x2, right? This fails the property of 1 to 1 function. So what is 1 to 1 function? If my x1 is not equal to x2, that means if I have different inputs, I should get different outputs, right? Distinct outputs, different outputs, both are same. So once I am taking 2 distinct inputs, I should get 2 distinct outputs. That is what 1 to 1 says. But if you see here, my x1 and x2 takes the same value, takes the same function value. These are all, this is a function, this polynomial is a function. So when I substitute x1, my p of x1 is same as p of x2. This fails the property of 1 to 1 function, failing that in this particular interval 2 to 3, my function is not 1 to 1. Okay.
Sir, sixth option correct or not, sir? Sir, this is a problem for me. My answer is wrong.
Your answer is correct.
So, sir, mock test include my number is wrong. This option tell me.
I will make it correct. Okay, don't worry.
Yeah, sir. Okay, sir. Thank you.
So this is how we check 1 to 1 on to. Don't worry, 1 to 1. This is how we check 1 to 1.
So question number 13.
Okay. So let's move to another question. So
Sir,
this
question
is about
4, please, first.
Question number 4, sir.
So what is question number 4?
Also, sir.
So question number 4 is if set A, that is 4, 5, 6, 7, and relation subset A cross A is an equivalence relation, what is the minimum number of elements of R must contain? So, sir, my doubt was that for R to be an equivalence relation, it has to be all transitive, symmetric, and reflexive. Yes, and for a function to be transitive, if A and AB is in the function and BC is in the relation, then AC should be in the relation. And for symmetric, AB and BA both should. If AB is in the relation, then BA should be in the relation. So, sir, if there is a relation that has only one element, 4, 4, 4, wouldn't that be equivalent as well? Because it will be reflexive because AB is not there, so it should not contain BA, and it will be transitive.
Wait. So this, don't worry about equivalence. Just tell me whether this is reflexive or not.
This is reflexive.
This is reflexive.
Yes.
Why?
No, sir.
Because for a comma a is in this.
Okay. So
this is reflexive because identity is included.
Reread
Sir,
the
all diagonal element होने चाहिए ना?
Yeah. So reread the definition of reflexive, or correct your reflexive definition.
Yes.
It should not be like for some A in the set A. It should be for all.
Okay, for reflexive, all the elements. Okay, okay.
For all A belonging to A comma A should belong to your relation.
Okay.
Okay. So this particular small A is like, it should be 4, 5, 6, 7 for all.
Okay, sir. Thank you, sir.
This is not reflexive.
Okay, sir. Thank you, sir. Thank you.
Okay. So so check this. This particular R, I define. I just take all the diagonal elements or all the elements which satisfy the reflexive property. So this actually satisfies symmetric, and this actually satisfies transitive also. Okay.
Yes, sir.
So this is the minimum number of elements required.
Move on, sir. Yes, sir.
So question number 13 now, sir.
Question number 10, sir. Please, एक बार.
Question number 7, sir.
Question 9, sir. Roller coaster problem.
Sir, don't you require different elements for
Sir, question number 6.
No. No need of different elements.
Oh, so sir, it is all the same. It is also transitive.
Right. This is transitive. See, if you have only one element, 1 comma 2, this is also transitive.
Oh, okay.
Because there is no 2 comma 1 to check, right?
Yeah, there is no other element, second element, in order to check for the third element.
Okay. So any
Question number
combination
10,
by
sir.
itself is transitive. Any combination by itself is transitive.
So 1 comma
Question number
1.
10, sir.
Yeah, I will. Just
Sir, another doubt.
1 second.
Sir, another doubt regarding this question only. Sir, if we have a set with the 1 comma 2, 2 comma 1, and 1 comma 1, will it be transitive?
1 comma 2,
2 comma 1, and then 1 comma 1.
Yeah, also.
Yeah.
This
tell me.
one is directly following the condition.
It will be again.
So this will, okay. This will be transitive, right?
Right.
Okay, thank you, sir.
Sir, question number 6.
I will go one by one, okay?
Sir, it won't be transitive, right? 1
Question
comma
number
2.
6 is done.
Sir, the last question, 1 comma 2 and 2 comma 1 is there, right? Okay.
This is
So
transitive.
shouldn't there be 2 comma 2 as well?
Why?
2 comma 1 and then 1 comma 2.
Correct. This is not transitive. 2 comma 2 should.
It won't be transitive.
Right. Correct. Thanks.
So why should 2 comma 2 be there?
See, this is AB. This is BC.
Yes, sir.
So you should have AC.
No, but we can also take it as AB in the first one, right? And
Yeah,
then
for all. Again, the transitive is for all.
For all, not for one.
Not for finding one particular set.
So a set is transitive unless you prove otherwise.
Yeah.
Sir, so how will this work for 1 comma 1?
How will this work for?
1 comma 1, the A comma B and B comma C.
Okay. See, 1 comma 1. This one, no?
No, sir, the last example.
When only one element is there, it will be transitive. Okay, 1 comma 1. There is no next element. If 1 comma 1 is there, the next element 1 comma 2 is there.
Okay. Thank
1
you.
comma 1, 1 comma 2. The ending starts with second element. 1 comma 2 is there. Then we will go for third pair.
Okay.
Yeah. If I get a contradiction like this, if I have some two pairs, A comma B, B comma C, belonging to my R, but I found that A comma C is not there in my R, then it is not transitive. If I find one pair like this is enough to break the property of transitivity. If I cannot find that pair, then it is transitive. Okay. So here I found if I don't have 2 comma 2, I have found the pair 2 comma 1, 1 comma 2 belonging to my R, but I cannot see this 2 comma 2 in my R. That means 2 comma 2 is not there in my R, making my property contradiction, bringing the contradiction to my property. So I have 2 elements with me. I don't have my third element. So I say this is not transitive.
Okay, sir.
So if I cannot find
But
it,
sir, in this question, if we say that 1 comma 2 is A comma B and 2 comma 1 is B comma C, then 1 comma 1 is A comma C is there.
Okay, for that is one particular case. Okay, that is what I am saying. You shouldn't find one particular case. You should find a case to break this property.
Yes, like in contradictory way.
Like contradictory way. If you can find two elements which are of the form A comma B and B comma C, and if your third element A comma C is not in your R, if you can find these 3 elements such that 2 elements are in your relation and third element is not there in your relation, then if you can come up with that contradictory example, then that will break the property of transitivity. If you cannot come up with that particular set, then it is transitive. Okay.
So that means for every set, we need to actually have the transitive.
For every set, for every element you should check.
For every element you want actually.
For every
start with the assumption that the set is transitive and then try to prove otherwise. If you can prove, then it is not transitive.
So I have to validate it for first element with the second and third, and second element with the third and first, and then again the third and first and second.
You can minimize your search. So when you are taking first element as 1 comma 2, then only look at the elements which starts with 2 actually. So no need for 2 and 3. It's enough for taking second element as second and look for the third, like this. You should check for each and every element, each and every pair. Each and every pair should be satisfied. Then only I will say it is transitive. So as someone mentioned, take that as a transitive and try to come up with a contradiction with 3 elements like these elements. So if you can come up with a contradiction, then it is not transitive. If you are unable to come up with a contradiction, then it is transitive itself. Same
Sir,
goes with
sir, the last question. Suppose in question we are being asked with this set only, this 1 1 2 2 1 and 1 1, and they are saying just prove if it's transitive or not. Then we can say it is transitive because it is. Suppose
It's not transitive. It's not transitive.
This one is not
No,
transitive.
you can't. Just take
There should be 2 comma 2
as
that
a
has to be transitive.
Right.
See, this is the contradiction I have gave you. So I have 2 comma 1, 1 comma 2, but I don't have 2 comma 2. I just found one case which is not being satisfied. So once, if I found one case, it is not transitive. If I am not able to find any of this, then it is transitive. This is not transitive.
Yes, sir. Okay, thank you.
Okay. So what about this Aishi wants to make a rectangular garden? See, these all are this solution. Once we release this solution, I guess it's easy. So other question, what is that?
Can we do question number 9 and 10?
Which one is that?
Yes, sir. Question number 10.
Yes, 9 and 10 let us discuss.
Aditya.
Question number 9 and 10.
Question number 7, sir.
Yeah. So see, let me do this Aditya thing. So Aditya is a roller coaster designer. He came up with the design of a roller coaster which is in the shape of a parabola. So we don't need that top statements. We just need this particular statement. One particular design is of shape of a parabola, and if you see the parabola, it is given as x square minus mx plus 1. Right? I say this as some f of x.
Yes, sir.
So see, the leading coefficient is positive. Right?
Sir, we will be getting a PDF of the solution on the dashboard, no?
Right. After this session.
Okay, sir.
So as the leading coefficient is positive,
Yeah.
you know that the graph is an upward parabola of this particular thing, right? So something, and also you know the y-intercept as 1. When I substitute x is equals to 0 is nothing but the y-intercept. It will be something like this. Something like this. Right? This is 1 comma 0. Now I also have his research on design led him to conclusion that the entire structure will collapse.
0, 1 होगा.
Sir,
0, comma.
the parabola should be on the positive side of x-axis, right?
Why?
The vertex coordinate, x coordinate of the vertex is minus b by 2 is positive here, right? Assuming that m is positive.
Assuming that m is positive. Who gave m is positive?
Oh, I'm just wondering, is there any reason that
See,
drawn on the left
no,
side?
something it can be like this also.
Yeah, that's what I'm saying.
It can be. Okay. So that the other thing will clarify whether it will be this thing or this thing.
Okay, right now we just assumed, right? Yeah.
We just assume.
Okay, sir. Fine.
But
Sir.
his research also tells that there is another line which is g of x is equal to x minus 3.
Yeah.
When this particular roller coaster design or this particular parabola touches that line x minus 3, then the whole whole thing will collapse. So just draw the graph of x minus 3. We know how to draw the graph of x minus 3. So how will that look?
So y-intercept will be minus 3 and x will be 3.
Right?
Yes, sir.
So this is g of x and g of x is x minus 3. So it's just like just substitute x is equals to 0, you will get the y-intercept. Substitute g of x is equals to 0, you will get the x-intercept. So 3 comma 0 and minus 3 comma 0. So what we said you is, if these two touches or intersects, that means if this function f of x and if this function g of x has a common value at some value x. So if intersects means, see, if my parabola is intersecting like this, that means at this particular point and at this particular point, if I take x is equals to this particular points, my function values are same. So my g of x value and my f of x value takes the same value at this particular value of x. Right? When I substitute this particular x, whether it is x1, if I substitute x1 in this function and in this function, my f of x1 is same as g of x1.
Yeah.
Right? So this shouldn't happen. That means f of x becoming equal to g of x shouldn't happen. That means there should be no x such that f of x is equal to g of x. So this is the key idea behind the question. So ultimately what you have to get from the data is, we shouldn't have, so no x should satisfy this condition that f of x becoming g of x. So if this is happening at for some value of x, that means at that value of x actually the graphs are being intersected or touches. So that is what we shouldn't want. So from this what we get is x square minus mx plus 1 x minus 3. So we got a quadratic equation. What we want is, we shouldn't have an x which satisfies this quadratic equation. Right?
Yeah.
So we have a quadratic equation which is like this: m plus 1 of x plus 4 is equal to 0.
Yeah.
Now see, this is a quadratic equation. This converts into a quadratic equation. If this is true, this will be true and this will be true for some value of x. So if I have a root, if I say alpha is a root of this quadratic equation, That means at x is equals to alpha, actually my graph touches or intersects.
Yeah.
Right?
Yeah.
So I shouldn't have any such alpha. That means I shouldn't have roots for this particular quadratic equation. If I don't have roots for this quadratic equation, that means I don't have some x value which will be, for which this particular x square minus mx plus 1 will be equal to x minus 3. So that means there will be no x such that f of x is equal to g of x, which tells me that these two curves will not intersect at all. So this is how we link the things. So this from this and this. So this is how this data is interlinked to this roots of this quadratic equation. Okay, ultimately what we have to find is find a value of m such that this particular quadratic equation will have no real roots. If it has no real roots, that means there will not be any x or any point at which these two functions will actually intersect. Got it? So there will be many possible values of m, out of which you can choose. You can choose -4 or -3, -2, -1, 0, 1, 2.
This -4 receive we can get. So discriminant part.
Yeah, the same thing. If it shouldn't have no, if it should have no real roots, means discriminant should be less than 0. So do it. Discriminant less than 0 means m plus 1 whole square minus 4 times of 4 should be less than 0. M square plus 2m plus 1, or you can directly do this. Your m plus 1 whole square should be less than 16. M plus 1 should be in between -4 and +4. Okay. So from this we get -5m less than 3. So your m should be in between -5 and 3. So that is what you will get. So solve this. So once you see the document which we release, you will get a clear idea.
Okay, sir.
So the idea is you should connect. So how this graph being linked with this particular function f of x is equals to g of x, and how this quadratic equation is being, roots of this quadratic equation is actually telling us what this roots tells us. So those are the points, those roots tells us those are the points at which actually the functions f of x and g of x meets. Okay. So that is what the first question is also about. So if f of x and g of x touches each other means, at a point touches each other means f of x is equal to g of x at that particular point. And also if Aditya makes sure that the structure do not collapse, then the discriminant of f of x minus g of x, which is the quadratic equation which we are seeing on the screen right now, must be less than 0. So if discriminant
Sir, but in first option, fx is equal to gx, is a question tell us that this is collapse is touches or intersect. So how can the fx are equal to gx?
Yeah, see, that is why we are, see, if f of x is equals to g of x, we are taking
Okay.
f of x is equals to g of x. Okay.
Yeah.
We are trying to find some x which satisfy this thing, and we got a quadratic equation. So we will say that there are two values of x for which this f of x and g of x can be equal if this particular quadratic equation has two real roots.
It means find a range between in the fx and gx, like. I'm wrong.
Sir, it
We
means
have to find
at
the
every
link
point
of
of m,
fx and gx.
for at every value of m, it will be collapse. It will be intersect.
Okay, we will see it in the other way. Okay, we will go backwards. So if this particular x square minus m, this particular quadratic equation has root, let us assume that this is having root alpha. So then I can say that alpha square minus m plus 1 times alpha plus 4 is equal to 0 satisfies this equation.
Yeah.
This is true.
Yeah.
Then I will write it like this: alpha square minus m alpha plus 1 is equals to alpha minus 3. I'm just taking this alpha minus alpha to the right hand side and 3 to the right hand side. Can I write it like this?
Okay, sir. Got it. Yes, sir.
Okay, sir. Okay, sir.
So for this particular
Sir,
alpha, I write it as
sir,
f of alpha is equals to g of alpha.
sir, it means alpha is a root of gx and fx both.
No, not the root. See, this is actually the value when I substitute alpha in my function f of x, right?
Yeah. Yes. Okay.
This is the value when I substitute alpha in my function g of x. So when I substitute alpha in place of x, I will get alpha minus 3, which is g of alpha. G of alpha is nothing but alpha minus 3, right? If g of x is x minus 3, what is alpha minus 3? G of alpha. I'm just going back. See,
Yes,
I
sir.
can write this function alpha minus 3 as g of alpha. This is where this is nothing but when I substitute alpha in my function g of x, I will get alpha minus 3. Right? Just substitute alpha. So I can replace this alpha minus 3 as g of alpha. So that is what. So from this, what we get is for this particular alpha, my function f of x and g of x being equal. When x is equals to alpha, f of alpha is being equal to g of alpha. So that means I can have a particular point x is equals to alpha where my function f of x and g of x actually intersects. Okay. So what I got is if I have a root alpha, then this is happening. This is happening. Intersection is being happening. So what I should have is I shouldn't have a root. I shouldn't have root at all. If I don't have a root, then I cannot find or I cannot have an x value such that f of x is being equal to g of x. So just interconnect. This is just the interconnection between the word statement and the mathematical statement.
It means, sir, minus 4 and minus 4 less than amount plus 1 is which range are value certified that not intersect.
Yeah. Range of values for m for which this particular quadratic equation will not have roots.
Yeah.
Okay.
Okay.
Yeah.
Okay.
So that is what we asked you also. The second question is that enter an integer value m such that the structure will not collapse. Structure will not collapse is same thing as f of x should not be equal to g of x. That means the quadratic equation should not have real roots. The same. Okay.
Yes, I got it, sir. Thank you, sir.
So we will release the solution.
Sir, first question, sir. Third option, why wrong? Little bit confused about this. Please tell me, sir.
First question.
Yeah,
what is first question?
Oh, 1 second, sir. So first one, fx is equal to x power 3 minus 6x square plus 9x minus 4 and gx is equal to minus fx. Respectively, choose the correct option from the following. And option is f is strictly increasing 4 to infinite. And second option is g has 2 turning point and there are no turning point with negative y accordingly.
Okay.
And
f of x is given as okay. I got the question.
Yes, sir. Yes.
Minus 6x square plus 9x minus 4.
Yes.
So what are the roots of this? Can I
look
at when I can I actually factorize this off? So when I substitute x, use trial and error method.
Yes, trial and x minus 1 is equal to 1 root. Find then another other method divide by all is this and find the other root.
Other roots. If you find the other roots also, you will get.
Yes, sir.
Okay.
X minus 1 whole square and x minus 4 will be root.
Right. So I can simply write it like this: x minus 1 square into x minus 4. Okay. Once you have polynomial of like this, like roots with multiplicities, you can actually sketch the graph, right?
Yeah, sir.
So how will the graph look like? F of x graph?
Sir, this is a odd degree plus infinite to minus infinite.
Odd degree.
And first coordinate to third coordinate is opposite side.
First coordinate. Right. So it will be like this.
Yes.
And it will go like this.
Yes.
Right? What happens in between? This is multiplicity 2.
Yes.
So at 1 it should bounce back.
Okay.
Right?
Yeah.
So it should reach 4. So this is how f of x graph. Somewhat it will be like this.
Yeah.
Okay. Now what is g of x? G of x is actually minus f of x. Right?
Yeah. Yeah.
So this is minus of x minus 1 whole square, x minus 4 whole square.
Mm.
Now what happened is the only change is our leading coefficient is negative here.
No.
Initially it is positive. So whole, so it is, you will get inverse image of this.
Yes, sir.
Okay.
Mm.
So when a is less than 0 and it is odd degree, and behavior will be like this. And at 1 it should bounce back like this. So this is g of x. Okay.
Yes.
Once you get the graph, just go through the options. Once you draw the graph, then go through the option. So f is strictly increasing in 4 to infinite.
Yeah.
So this is 4 and to infinite. So what happens in this particular interval? Is it increasing or decreasing?
Increasing, sir.
Increasing.
4 to infinite is increasing.
4 to increasing. F of x is increasing. What happens to g of x?
G of x is decreasing, sir. Like.
Yeah. So in this interval 4 to infinite, f of x will be increasing, g of x is decreasing. So our first option states that f of x is an increasing in the interval 4 to infinite. So is it correct or wrong?
It's correct.
So now the second statement is g has 2 turning points and there are no turning points with negative y coordinate.
Yes.
Okay. So what are the two how many turning points did g has?
G had 2, sir. One and another is a
this is
downward parabola max vertex.
Yeah. This is 1 and this is 2. Two turning points, right?
Yes.
So what is the y coordinate of this turning point? First turning point?
First is y coordinate 0, sir.
0. And this thing?
This it look like, sir.
Whether it is positive or negative, that is sufficient.
Positive.
Only positive, negative. Y coordinate is positive.
Yes, sir.
Right? So one y coordinate is 0 and another y coordinate is positive.
Yes.
So what the statement is saying, z has 2 turning points and there are no turning points with negative y coordinate. So is this statement correct or false?
Yes, sir. Correct, sir.
And what is the next statement? F has 2 turning points and x coordinates of both the turning points are negative.
Yes, sir. This is my problem, sir.
Incorrect, sir. It will be incorrect.
What are the 2 turning points x has?
X has a 1 and
f of x.
Yes,
1 and
1 and upward parabola vertex.
This one, right?
Yes.
Downward wala. This is f of x.
Yes,
blue one is f of x. Now we are talking about f function f, graph of f. Okay. Option 3 is about the graph of f. Okay. These are the 2 turning.
Sir, it means that this is what y coordinate is a minus y minus, sir.
Y coordinate can have minus, but read the question. Now we are asking you f has 2 turning points and the x coordinates of both the turning points are negative.
Yes, sir.
So what is the x coordinate of this first turning point?
First coordinate is positive, sir.
Positive. What is the x coordinate of this turning point?
X coordinate is also positive.
Positive. Y coordinate is negative here.
Yeah, sir.
Okay. Now we have 2 positive coordinates, but the statement tells us that both the turning points are negative. X coordinates of both the turning points are negative.
Yeah, sir.
So that is wrong, right?
This is a two x-axis are positive. So this is a wrong answer.
Wrong.
Well, sir,
Similarly, check for option 4.
Sir, I have a doubt. Sir, same logic I have applied.
Thanks, sir.
Question number.
Question
Same
number.
logic I have applied. Assignment. Question number 2, sir.
Question number
Sir,
2.
but
Can you
my
read out the question
answer
number?
is wrong. Option number 3.
Option number 3.
If
Hello,
in the
sir.
relation.
One second. Divyanshu, can you read the question, please?
Yes, yes, sir. Sir, fx is equal to x cube minus 6x square.
So this is the
plus
question,
9x
right?
minus
This is
4.
what the question, right?
Okay.
So whatever you
And
are
gx
seeing,
is equal to minus 2 f(x). Minus 2 f of x.
Which question is this?
Sir, graded assignment, sir. Graded assignment.
Okay, you
4.
are talking about graded assignment.
Yes, sir.
Okay, the same question, but there is minus 2 times of f of x.
Yes, sir.
Oh, okay. Now there is, let us say, h of x. I have minus 2 times of f of x.
F of x. Yes, sir.
So this is minus 2 times of x minus 1 whole square, x minus 4 whole square. Right?
Yes, sir. Yes, sir.
Now what happens is, this is actually stretching, just the stretching. It doesn't impact any roots, or it is not impacting any multiplicity. But look, the graph will be like this. Okay. Oh, sorry, sir. It will not go.
No, sir. Sir, it should be download, no, sir.
It will go.
Yes, sir.
Okay. Yeah, this is how h of x will be. So what was the problem now?
Sir, I have a problem in option number 3.
What it states?
Sir, f has 2 turning points and y coordinate of only 1 turning point is positive.
Okay. So in your case, it should be correct or wrong?
Sir, Sir, option number 4. G has 2 turning points and x coordinate of both the turning points are negative, sir.
X coordinate of both the turning points are negative.
Yes, sir.
So, that should be wrong answer.
Sir, but it will be correct here, sir.
Why?
Sir, I don't know, sir, why.
It is given correct, huh?
Yes, sir.
1 second, let me check.
Correct that G has 2 turning points and y coordinates of only 1 turning point is positive.
Week 4.
G has 2 turning points.
1 second, I am just opening.
G has 2 turning points and y coordinate of only 1 turning point is positive.
G and H both have 2 turning points, and both have 1 turning point that is positive y. Another is 0.
Another is 0. Correct. So I'm just looking at the statement.
Sir, option number 2.
Question number
2. Z has 2 turning points.
And y coordinate of only 1 turning point is positive.
Yes, sir. Here is both positive, no, sir.
Y coordinate?
Yes,
no,
sir.
One is positive, other is 0.
So what is the y coordinate of this particular turning point?
Who is it?
This one. These are the 2 turning points, right? Green
Yes,
graph, h of x. This one and this one.
Sir, which is one is positive, sir.
This is positive. Okay.
And this is also positive.
This is y coordinate. What is the y coordinate of this particular turning point?
Sir, 0.
0. Is 0 positive or?
Sir, we can't say that about.
0 is neither positive nor negative.
Indirectly, sir.
Okay, it is neither. It is not even positive, it is not even negative.
We should
Okay.
not account it.
So in the questions, when we talk about roots, do we mean like implicitly that we are talking about real roots?
Right.
Okay.
Sir, can you please explain the roots, sir?
Sir, thank you, sir.
Roots
And also,
of
sir, if the root is getting repeated, we should not count it, right? That's what
no. As of now, no. In this course, no.
Okay.
So you say this particular polynomial has 2 roots.
Can we discuss question 13 and 14?
Okay, what is
from
13
the
and
mock
14?
test?
Yeah, 13 and 14. What is 13 and 14?
1 minute, sir.
Ministry.
Sir, that Ministry of Road problem.
The Ministry of Road wants to connect 3 districts with 2 roads, R1 and R2.
The
The shape of 2 roads.
Got it.
Okay, sir.
So this was already like, it's a direct question from graded, right? Graded or?
Yes, sir, direct question from.
Why not check back the graded solution, or you will get the solution of this pretty soon. So it's like, see, you have given f of x and g of x to you, and wherever the graph of f of x and g of x intersects, so those are the aspirational districts. Okay, try to draw the graph of this f of x and g of x. It will give you a lot clarity. What is f of x actually? F of x is nothing but the square of g of x. Once you factorize it, what you will get is this thing. F of x is actually g of x whole square. Okay, factorize f of x first, and then you will see f of x is actually x minus 5 whole square into x minus 3 whole square, which is nothing but square of g of x polynomial. Okay, once you got that, just draw the graphs of f of x and g of x and see where the graph, where the 2 graphs are intersecting, and they are the actually it is from the question itself you can conclude that f of x and g of x actually intersects at 3 points, because we directly gave that there are 3 aspirational districts. Okay, so you just plot this.
Sir, in question number 12, sir, how we calculate height?
Okay, let me complete this. You just 3, 5. You know that this is f of x. Once you calculate this is f of x, at x minus 5 and x minus 3, 3 and 5 are the roots, and at both the things has multiplicity 2, and it is an even degree. So your f of x will be something like this, and you have g of x as minus of x minus 5 into x minus 3, even degree with the negative coefficient. Even degree with negative coefficient will actually be like this. 3, it intersects here, and it is said that like this. So this is 1, this is 2, and this is 3. These are the 3 aspirational districts. So this is g of x, this is f of x. So now it's a matter of finding what we asked you is, if g of x divides f of x, then find the number of real roots of f of x. So how many roots are there for f of x? Who asked this question?
Sir, I think she left. I don't.
Okay.
Graph between 3 and 5 for both the equation would completely overlap, right?
No, see, it will not overlap. It will go up.
It's possible because they are both intersecting at same point on axis, and then they have another third point that is.
Yeah, see, we directly said that actually f of x and g of x intersects only at 3 points. Okay.
Okay.
Well, even if you draw these graphs of f of x and g of x in decimals, you will get pretty much same graph. Or not same graph, roughly this graph.
Okay.
Sir.
हाँ.
Sir, x square plus 1 इसके कितने रूट्स होंगे?
0. So graph of x square plus 1. Draw the graph of x square plus 1. So how will the graph of x square plus 1 look like?
Yes, sir.
Like this. So how many times it is being intersected with x-axis?
0 times, sir.
0 times. So there are no real roots for that.
Sir, the repeated root हम लोग count करते हैं?
No.
2 times count करेंगे?
No. As of now in this course, we are not counting. But the thing is, see, that depends on the convention we take. So some people say there are 2 roots. Some for this particular quadratic equation x minus 3 whole square. Some say there are 2 roots 3 comma 3. Those are the kind of people.
So 2 roots means 2 real root, no?
2 real roots 3 comma 3 which are equal. So this is also correct statement. This is a correct statement. And also when we are dealing with multiplicity, we in this particular course what we treat it is this has one real root 3 with multiplicity 2.
Sir, -3 और 3 ये distinct real root है कि सिर्फ real root है?
-3 and 3 are distinct. -3 is distinct from 3. -3 is actually different from 3.
तो मतलब repeated root distinct नहीं होते हैं?
Repeated root
distinct नहीं होते हैं?
नहीं होते. Repeated roots are same value. 3 3 2 2 4 4 same thing. Okay.
They are counted in only one real root, no?
We count in this course as we are dealing with multiplicities also, as we have introduced that term multiplicity also. We say this particular quadratic equation has one root with multiplicity 2. Okay. Or when I say this is some polynomial p of x, this polynomial has one root which is 3 with multiplicity 2. Okay. Yeah. I don't say that we shouldn't say it has 2 roots, but we use this convention. Both are correct, but we follow this.
Sir. Sir, mock question number 7. Sir, equation बता सकते हैं आप इसकी?
Question number 7. Can you read out the question? I have.
Sir, please complete this 14 also. Same continuation question. 13 and 14.
Okay. 14 is, see, what we want
Same
is,
like 14 is same like the assignment question number 5.
So, sir, the last conversion that we just had on real roots. So if we are being asked like how many real roots are there, does it mean like how many distinct real roots are there? Should we
distinct real roots? Yeah. Distinct real roots.
If we are being asked about the count of real roots, it is basically the distinct that is being asked.
Distinct. Yeah. In this particular course, we treat when we are asking the number of real roots, generally it means distinct real roots.
Okay.
Okay.
Yes, sir. Thank you.
In question number 14, aspirational means aspirational district.
Some sort of good districts or why are you bothering about aspirational? Nothing to do with aspirational.
I thought about some technical term related to.
No, it's not technical term. See, it's just for we want to confuse you, or we feel like you should read more.
Okay.
Sir, can I ask one doubt regarding this practice assignment 3.4? I have a doubt in practice assignment 3.4.
Okay, so yeah, this is about mock test questions. Rest of the questions, like I guess.
Sir, question number 11, sir. Question: how to find the height Basically, that time.
Please complete question number 14, please, sir.
14. See, what is the x coordinate of the third aspirational district? We know two. These are the. This is 1. This is first. This is second. We want the coordinate of this particular x
सर
coordinate.
सिंपल सा उसमें दिया है कि डिवाइड मतलब डिवाइड कर रहा है एफ जी ऑफ एक्स डिवाइड कर रहा है एफ ऑफ एक्स को, तो एफ ऑफ एक्स इक्वल टू जी ऑफ एक्स, तो फिर सिर्फ वैल्यू रख के निकाल लेंगे तो फिर सर थर्ड की वैल्यू आ जाएगी x माइनस 4 का होल स्क्वायर.
It's
तो
actually,
फिर जो
you know,
So this is also covered in the solve with instructor session.
Previous session, yes.
And
Yeah,
if they
yeah,
go through the slides, they will know the exact solution how it
See,
works.
assignment question number 5.
This is directly the assignment question number 5. Yeah, someone is mentioning. So how you solve the text question? The same approach for this particular question also. You will see pretty much same, some questions, same questions involving activity or practice or.
See, there was a trick also. The answer in the question assignment and all these three things follow a pattern. If you observe that, you'll be able to look into the answer without much math.
Okay, then we will break that pattern in future. Thanks for giving this in front of.
Yes, sir. Basically, sir told that if 3 or 5th is given, 4 will be absolutely will be the third point.
Acha, 4 will be. Yeah? Now this time I will give 4.25.
यार क्यों यार आप हमने आपका क्या बिगाड़ा? What did we do to you?
No, nothing like that.
भाई
See,
ऐसे क्यों कर
papers
रहे
are
भाई, टाइम
already
लग
prepared
जाएगा
and
ज्यादा.
don't worry.
So are we going to have another mock?
No, nothing related to mock. See, that is why today's session is wholly on mock. We will
So
relate
we
the
are not going to have
particular-
any more mocks in maths for qualify for the first
not,
quiz.
No timed mocks, but maybe you can get one more practice.
Is there any
Okay, so because this was very similar to September, not exactly, but very similar to the last qualifier.
Last qualifier?
Really?
Yes.
Acha, this mock. Yeah.
Mock was very
Yeah,
similar.
Correct.
ओह सर, तभी तो ग्रुप में सब आंसर ही बता रहे थे आधे घंटे पहले ही.
The entire replica of the previous.
You are sharing answers.
So it did not give a feel of solving a mock, because when you know the method, and I, for example, also remembered some of the answers, so it took the fun out of solving the mock.
Okay, then let me here. So
Sir,
once
basically,
we have
Use
given
the
you
language and change the value on this question.
No. Once we have given you this is the mock, you can relate with this with upcoming qualifier actually.
Sir, मुझे लगता है
This is
कि
resembling last time's quiz paper. This mock is pretty much same as last time quiz paper, but we are actually giving that as a mock. This should tell you something, right? So when we are
and
giving
I think I remember that IIT never वो कॉपी करता है क्वेश्चन को.
हेलो सर.
IIT never repeat that
IIT
question.
में से कॉपी कर सकता है.
Hello, sir.
So, but last time when I given the mock,
Hello, sir. I have a general question. I reapplied for Qualifier this time, but my quantitative exam is clashing with a Qualifier exam on 30th Jan. So if I am not present to give a Qualifier exam, then can I give in 13th of March? 13th March.
No, see, I just got a clarity regarding this. When you are applying for Qualifier 2, which is going to happen on March 13, you will get enrollment for next term, which is May term. Okay. You cannot continue in this term. So it's just for students who shouldn't wait till May term start. They can give the Qualifier in upcoming March 13.
So सर अगर मैं अभी मतलब 13th मार्च को देता हूँ तो मेरे को मई टर्म से कंटिन्यू करना पड़ेगा.
अगला टर्म से
May term.
May term.
Sorry, sir, I did not get that. Can you please repeat it?
But sir, don't worry. Even this information I got recently, but this will get to you guys as an announcement or some sort of session. They will keep it and they will explain you how this works. So you will get a much
But
more.
sir, I will eligible for the 13th March qualifier if I will absent in 13th June. Jen.
Sure.
You are eligible. See, that particular March 13 exam is for the students who fail to crack this or who are absent for this exam.
Okay.
Who will fail, they will reapply, and who will absent, they will direct to eligible to sit the exam.
Sir,
I think.
one more small doubt, sir. If we are going to write on March 13th as exam, but we need to submit all this week 5, 6 and all the graded?
No.
No, we should not do.
No.
Only for week 2.
This is just like another exam for the people who failed or who are absent. Okay.
No, sir. Actually, I need some more. So I should stop from up to 4th graded.
Yeah, you should stop till week 4 and you just start preparing again for week 1, taking the contents week 1 to 4 in February and appear for the exam in the March.
Okay, after March qualifier, then I need to submit remaining 5, 6 and weeks. Again, we will get.
Not this term.
Yes, sir. Oh, yeah. Some
May you will be directly entered into term.
Okay.
But sir,
question number 11.
Answer for term students?
For term students, this is like a quiz, right?
Right. So the one in March will be the quiz 2, which will be
one in March will be the quiz 2.
week 7 or 5 onwards.
Both are different. Qualifier paper 2 is different from quiz 2.
सर वहां पर बस एब्सेंट्स वालों के लिए लिखा हुआ है कि वो मार्च 13 को दे सकते हैं. अगर वो कोई फेल हो जाते हैं तो वो भी दे सकते हैं क्या?
Fail also. That is what I got. So yeah, even I am not pretty much 100% confident. You should not rely on me. You will get an formal announcement or such regarding this and a better understanding with some of the trusted.
In a announcement only absence is included, that's why.
No.
नहीं, जो फेल होंगे वो आधी फीस पे, मतलब 1500 पे रिप्लाई करके वो एलिजिबल होंगे.
Okay, let's come back and
what is the announcement you're saying, sir?
One point
maybe
I am to ask. I am waiting for that. So the thing is, I am appearing for the qualifier first time. Okay. So just wanted to have an experience that the mock and the qualifier are in the similar lines, or they are a bit different. Like those who have experience, can you please share your experience? Like usually, if you are good in, I suppose you have appeared for a mock, whether it is kind of similar in the final qualifier.
Now is not a good time, I guess. You can
okay.
ask it in some other forums or.
Sure.
Right.
Question
number 11.
Which week of content is important for preparation?
All the weeks.
We have been asking
all the weeks. See, as we have only 4 weeks and we have to give you a paper of 100 marks. So more or less each and every week will be of 20 to 30 marks. What is question number 11?
Okay.
Can you read it out?
Yes, sir. A well-educated carpenter is asked to...
Okay.
It is continued.
Okay. So what is the doubt here?
Sir,
how can we find
I got the answer, but not very aware about the process, basically, how to do.
Basically, this is all this particular data is actually related to SSE. So that you can identify or not?
Okay.
Can you identify that?
Related to SSE?
Sum squared error. SSE. Sum squared error. Yeah.
Okay. I will do that.
Yeah. So once you see the solution, I hope you will understand it clearly.
Okay.
Apart from mock,
that time, basically, I have solved it when I putting the value of a 1 and a 2, value of x in this given equation px. Then after that, I got some y value, and then I got to conclusion. Okay, 18 is the height, and after that, and also find the value of a k. But
Okay. So this thing you got right. You got like 20 to 30% of it. But keep this in when you want to keep this all things in mathematics.
SSE. Okay. Yes.
That thing you should keep it. You can see it in through SSC. So we'll see the solution. You will get it by tonight. Okay. Solutions you will get it by tonight.
Okay. And one more thing, sir. Related to I think square. Asis want to make a rectangular garden with 100 feet fence.
Okay.
Yes, sir. Same.
Okay.
Can I?
So idea is like this. So you know that rectangular garden has some length and some breadth, right?
Yeah. Yes, sir.
So he just wanted to adjust the length so that she get the maximum area possible for the garden. Okay.
Yeah. Yes.
Just take length is something.
Okay.
If you want to make a rectangular garden with 100
So
feet
you are
fence.
drawing something on a screen?
No. I will just draw it.
Okay.
Okay. I have 100 feet fence. Okay.
Yes.
Now I am making a rectangular fence.
Yeah.
This is length L and this is breadth B.
Okay.
Okay, this is L and this is B. Now what is this 100 telling me? I have 100 feet fence and I am making a fence of rectangular garden. So I should
This
fence
100
here.
feet is the circumference of the
Total perimeters.
Total perimeter.
Total perimeter.
Perimeter.
Yeah.
Yeah, perimeter.
So, when rectangular thing, it is perimeter.
Perimeter,
Circle,
yes.
it is circumference.
Circumference, yes.
Yeah. Now we said it is rectangle. So what
Yeah.
it tells me that L plus B plus L plus B is actually 100.
100. Yeah.
This is what we have given you, right?
Yeah.
So L plus B, I get 50. From this, I have B is equals to 50 minus L, right?
Yeah.
I can
Yes.
write breadth in terms of length.
Yes.
Okay. Now you know area. What is the area of this rectangle?
L into B.
L into B. So L into B, I just substitute this.
L into B.
Okay. Now this is a quadratic equation in terms of L, right?
L.
L minus L square. And this particular thing is the area. I just want the maximum. I just want to maximize this. So this is a function.
Yeah.
Area is a function of L. And I have to maximize this function. So
Okay.
where will, if this is the parabola, where will the maximum lie?
At G.
Now we entered into
we find the maximum.
Technical terms.
The vertex.
Now we have a function, something f of L as 50L minus L square. So in order to find the maximum value attained by f of L, maximum will be attained at vertex point. Right?
Right.
Yes, sir.
Yeah.
Minus B by
What
2,
is the
right?
vertex point for this?
50 divided by 25.
Minus 50 divided by minus 2. Sorry, 2 into
25.
minus 1. Yeah. 25. So when my length is 25 meters, I will actually get maximum area.
Maximum.
Right?
Right. So
if my length is 25, what will be my breadth? If it is 25.
breadth will be at 25.
Breadth will also be 25 feet.
75.
Now you can see 75. No,
25.
see 50 minus L is the breadth.
25. 25.
Yes, sir.
25. So this is 25. This is 25. This is 25. This is 25. So you can see total fence is 100.
100.
So each of this length is 25.
25.
Right. So what is the length of the rectangular garden? So as to get the maximum possible area. And what will be the maximum possible area of the rectangular garden? What is the maximum possible area?
625.
625.
625.
Yeah. Fine.
Yes.
So that is all. See,
Good, sir.
yeah, every time
Hello,
I say
sir.
this thing.
Hello,
Key idea
sir.
is getting
Hello.
this particular statements to in mathematical terms. Once you get
Yes.
that,
In a quadratic.
Sir, to get maxima or minima, we can derivate, sir.
if you know derivatives, it's piece of cake for you.
Hello, sir. Okay.
Sir, a little bit confusion and decreasing, increasing. Sir, minus infinite to assume minus infinite to minus 2. Sir, you already tell this is a decrease. Uh, but I'm confused like as a minus 500 and minus 2 is a minus 2 is little bit more than minus 500. So this is a like a increasing minus 500
or
minus
this one?
400 is a, this is a
What he meant
increasing
was
function like
decrease in y value, not x value. Minus infinite to minus 2 is increasing in terms of x, but in this graph, the y value is decreasing.
See, don't worry about.
Sir, this is a problem, big problem.
Yeah. See,
Solving
don't worry
question.
about whether you should increase x or decrease x or.
Yes, sir. Yeah, this is a
Constant
confused option is wrong many times.
When you have the graph with you,
Yes.
just in general, you proceed like what happens when I keep on increasing x. Okay.
Yeah.
When I start from here, I will move to the right side. So when I
Yeah.
move right side of my x-axis,
Yeah.
x value will keep on increasing. So whatever the value here will be lesser than whatever the value here, will be lesser than whatever the value here, will be lesser than 0. These all values are lesser than 0, and these are all
Yeah.
0, and this is infinite.
Yes.
This is minus infinite, this is plus infinite.
And y value is decreasing.
Yeah, when I move to right side on my x-axis, actually my x is increasing. Okay.
Yes.
Don't even worry about what happens when x is decreasing. I should also do that. When you want to find whether the function is increasing or decreasing, you can do either ways, but follow one convention.
Yes.
Follow this convention. What happens to your graph when I move along right side of x-axis? So if your graph is coming downwards, or
Yes.
when your graph value of y value keep on decreasing, if you moving right side of x-axis, then it is a decreasing function.
Answer. This means decreasing function when I see y axis value decreasing, then like is a decreasing function. Yeah, depend on the y axis. Yes, sir.
Depending on the y axis,
This
you
depend like
see
like, it means that function depend on the y axis value or not.
it will depend on y values also. That is what we are seeing. When you are moving right side on x-axis,
Yeah.
what happens to your y values, whether it is decreasing or increasing?
This is a decreasing, like y axis is decreasing.
Yeah. So I start from here. I start from here means I am actually starting from here.
Yes. Yeah.
Okay. From here, this has some x coordinate and this has some y coordinate. At this point,
Yeah.
it has x coordinate and this has some y coordinate. So I
Yeah.
start moving on the graph. Okay, to the right side. To the
Yeah.
right side. Okay, when I move like that, after some time, I will stop at one more point, and I will have some other x coordinate and some other y coordinate, right?
Yes.
When you are moving to the right side of your graph, definitely your x coordinate will increase. Okay.
Yeah.
So just worry about the y coordinate now.
Yeah.
So look at the values of this y coordinate and this y coordinate. If this y coordinate is greater than this y coordinate, then it is decreasing. If this y coordinate is lesser than this y coordinate, in this cases.
Yes.
See, from here to here, on the graph you move right side. Okay, you start
Yes.
from this point and you move right side. Here you see there is x coordinate and y coordinate. There is some x coordinate and y coordinate. Okay.
This mean depend on the x value and y value both. Yes.
Simply it is what happens if I increase my x, what happens to the value of y, whether it is increasing or decreasing. If my y value is also increasing, it is an increasing function. If my y value is decreasing, it is a decreasing function.
Yes.
Okay.
Vice versa, like as y decreases, then x is increases.
Okay.
Like a decreasing function. Yes, sir. Okay, sir.
Sir,
Thank you, sir.
can we do one more question?
Yeah.
Okay, sir. Question number 9 from mock test.
Can you read out the question?
Oh, for sure. Aditya is a roller coaster designer.
That was just now discussed. Okay. Just go
Okay,
back.
so I
half an
have
hour
to
back.
rewind the video.
Yeah, you just go back half an hour or 45 minutes. Just you will get.
Hello, sir.
Yeah, hello.
Sir,
Hello. Sir, scroll down is screen. I want screenshot. You discuss, sir.
Okay.
Okay.
Hello, sir. Can you please explain the
Thank you,
roots
sir.
of a polynomial
Done, sir.
function for one equation? I'm little bit confused about the roots.
Okay.
For the first question, sir.
This one, no?
Sir, please explain me the roots.
Okay. Whenever a cubic polynomial is given to you, first root is like you should get it by trial and error method. Okay.
Okay, sir.
Just start with x is equals to 0, then give x is equals to 1, then give x is equals to -1, and x is equals to 2, x is equals to -2, x is equals to 3, x is equals to -3. Worst case is you will not get any of this thing. But good thing is in our course, if you try this, till here it is sufficient. 1 in 100 chances, like you should also check for x is equals to 3 and x is equals to -3.
Okay.
Okay, just check by substituting x is equals to 0. If your function f of 0 is 0, then x is a root. X is equals to 0 is a root. Okay. Likewise, if you check when I substitute x is equals to 1, f of 1 is actually 1 cube minus 6 plus 9 minus 4, which is actually 0. Okay.
Okay.
Which implies me that x is equals to 1 is a root.
Okay.
Okay, once you get that, use the division. X is equals to 1 is a root. That means x minus 1 is a factor of
f of x.
Polynomial f of x.
Okay.
So I have x minus 1. I know how to perform this division algorithm. Just
As usual, like
x square minus 5x square.
Sir, for second function, we need to change the sign of each time. Like if it will be minus, we need to change it to plus.
Yeah.
For every time.
Yeah, for every time. So it's just like subtraction.
Okay.
So if you want to subtract this polynomial with this polynomial, this is minus of this. So you'll automatically get interesting.
Yeah. Okay.
Okay. So this is plus 5x plus minus 4x plus 4 plus 1. What is this? This is minus
4x.
4, right?
Yeah, minus 4. Sir.
This is 0.
Is 0.
So now you can see f of x can be rewritten like this: x minus 1 times x square minus 5x plus 4.
5x plus 4.
Now this x square minus 5x 4 is nothing but x minus 1 into x minus 4. Okay. Ultimately, we'll get x minus 1 whole square times x minus 1. Okay. Any other questions other than mock?
Sir, for this type of question, first of all, we need to find the first root. If it will be power of 4 something 5 6 like that, this is the same process.
Power of 4 also same process.
Okay.
Power of 5, we are not that cruel to ask you the roots of 5-degree polynomial.
Yeah. Okay.
Okay.
Thank you, sir.
Yeah. And yeah. Okay. Can we close this then? Okay.
Sir, one general question, sir. Questions for the qualifier will be this much of level of difficulty or any more than this?
Not more than this. I can assure you that mock is the highest level of difficulty.
Okay, sir. Like if we solve all the like graded as assignments and practice assignments, Practice assignment questions also a little bit difficult in the nature.
Right. So if you solve, not only solving, see, understand how that method works. Okay.
Okay.
See, in the practice assignment, we might be asking you something like, in order to maximize the rectangular area, what is the length? When it comes to qualifier or something like given a bigger region, combining 2-3 areas, in order to maximize that, what should I do? So the key idea behind is not just following the method. The key idea behind is you
applying all the
coming up
concepts.
with a quadratic equation or polynomial. In order to find the maximum, we are just looking at the vertex point. Okay.
Okay, sir.
So that is what you have to get from that question. So
Okay.
when I want to find the maximum, minimum, or I should convert some data into a quadratic equation. If I convert that, I can actually find the maximum or minimum.
Okay, sir.
Sir, only one last question. So basically, I wasn't able to figure out the question sec. Give me a moment. I wrote it. I jotted that question down. So there was question 2 in GRPA 3. So I wasn't. So even I checked the solution, but I wasn't able to figure that out. How come that
What is
fourth option is?
GRPA 3?
Sorry, sir, not GRPA. Graded assignment 3.
Okay, graded assignment 3.
So yeah, question number 2. So question was like fine. I understood the question wherein there was a table manufacturing raw material miscellaneous, and Surya's designing a bicycle. So there was
Okay.
fourth option, which is like I marked it as correct.
See, fourth option is removed, right? It is not correct.
Yes. So basically, I'm not sure why it is not correct because this is the equation which is giving us the answer.
Okay. So see, what am I taking x here? That is most important. What is my x-axis here? So the total profit obtained by Surya by selling X bicycles. X is basically the number of bicycles.
Yes, sir.
Okay. X is not the selling price.
Yes, sir.
If X would have been the selling price, then the equation which is shown in the option 4 would have been correct.
Okay, so if I say that if this X they mentioned by selling X bicycles, if they remove this X in the option, then it is correct.
X in the
there's an
if the
option.
statement is like this, the total profit obtained by Surya by keeping the selling price of bicycle as X rupees.
Yes, they have mentioned that by Surya by selling X bicycles is this. So if they remove the X from the statement, then it is correct.
Maybe the total profit obtained by
Surya
by selling bicycles at X rupees is minus X square plus 840 X. See, X should be the selling price if your equation should be correct. Okay, but we have given X as number of bicycles.
Yes, they have sent by selling X bicycles. Okay. 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 Thank you,
in
sir.
the solution, we have shown you two cases. You can see in the solution, when X is number of bicycles and when X is selling price, there will be two different equations you will get.
Yes, sir. Yes, sir. I saw that. So okay. Now I got it. Thank you, sir.
Okay, thank you. So okay then. Thanks a lot and have a
Thank you,
good
sir,
day.
for the session. Yeah.
So
Thank
I
you.
have I wanted to say something not related to the course as such, but if you could pass on this message to the team who takes a call on the final scoring and all. If I could I won't take more than 2 minutes. I see that already there has been a change in the final scoring, and it has changed further with now I think bonus marks have been increased from 10 to 15. So if you could just convey the message to consider the working professionals who are also taking up the course, because if 15 marks are up for grab, bonus marks, basis, discourse, and 25. So 25% of live sessions I can manage. But as a working professional who's doing work also and studying, there's not much time left to go on discourse and be active there, trying to score 5 marks that are up for grab.
Okay. So let me tell you one thing. See, these bonus marks are actually the bonus. The term itself tells you that It's actually an extra marks.
But there's some new communication. It is not come in the latest updates, but in email, which says that it will be considered if because of some reason someone misses misses their one of the quizzes. So now instead of 10, they've increased it to 15, and as it is even for the live sessions that are there, it's also a struggle while juggling your office calls and being online. Usually, the last time I used to do it, I used to watch it later on weekends on YouTube.
Okay.
But now if at least one of them one has to do it live to complete the 25% quota.
Okay, right. Okay. Whatever you are saying is okay, valid to me. But our concern is, see, the bonus is actually why we came up this bonus idea is because of, see, there are students who are doing much good things like attending this live sessions or answering in discourse, but might not have been performing well in the end terms. Okay, so for them, what happens is they are passing the course anyway. This bonus marks are effective only when you pass the course. Okay,
right.
So it won't be considered if you fail. So but what happens is, even the students spend lots and lots of time in this course, if he is not able to perform well in the end term, we are giving him something like B grade or C grade or even lesser grade. Okay. So this bonus marks are just for increasing grades. That's it. So if you got B, and if you have done much good work, good pretty stuff by, not good, I don't say good, but if you are spending some time, investing some of your time in answering in discourse or helping others or attending these live sessions or something, like you are spending some sort of time in this particular course by submitting practice assignments, graded assignments, all such things you are doing, and you are investing your time actually, right? You are investing your time, and we want to give some incentive by giving an increase of grade. That's it. If you are spending a lot of time with us, so you haven't done good in the end term, okay, it's fine. We will, instead of giving you B, if you have some good set of bonus marks with you, we will add those bonus marks and make your grade as A. That's it. It just changes grade B to grade A if you have that 10 marks or 15 marks. So this is just for grade increasing. This doesn't impact. This is independent of, if you are doing statistics also. This is independent. See, one particular student score is independent of other student score, right? So other guy
This is
getting
not
A grade is different or independent. You getting some grade. Okay, it doesn't take you nothing. What I wanted to tell is, it doesn't impact your grades.
So grades are not relative, sir.
Grades are
absolute.
not relative basically.
Yeah.
Okay. So how much you score, we will grade it accordingly.
So there was something written that the marks will come up to 95. The grading pattern calculation, it sums up to 95, taking the best quiz into account. So that's what I thought. There is like 5 marks gap which they are trying to cover up with increasing the bonus marks to 15.
I don't.
For that 5 marks, I was saying, because that still gets affected.
That
There's
is
some new
for
communication. It is on email,
who.
but not on the latest updates yet.
Okay, let me see. See, this bonus marks will never impact someone so badly. This is just the bonus. So one people who are spending or investing time, we are giving some incentive which are independent from others, and others who are unable to who are unable to get this bonus.
I understand. I understand. That's why I did not bring it up before, but now it mentions that if you miss a quiz, because it's uncertain times are back again.
Right.
So there, if you miss one quiz, your marks come to 95. So those remaining 5 will be compensated by increasing the bonus marks from 10 to 15.
See,
so there it comes in picture where it does affect. So
correct. There it's like, see, the thing is, if you are missing a quiz, if you are unable to invest time in this, you will be scored for
it's
95%.
not about investing time. It is more about, though I will give the quiz, I am, but still there's there's a risk attached to it, right? What if I go and attend and I come back catching COVID? So yeah, that risk is always there.
100%, I guess.
I
Your
think for
grades.
qualifier, I attended qualifier in October. I qualified, but I took only 2 subjects, English and CT. And what I observed is that I could not attend even a single session. And now this time, this is the first time that I have just missed 2 of the math session, and I'm attending everything and I am giving my best. But yeah, it's only possible if I take 1 subject per sem since I'm working. It's what I feel. And qualifier first 4 weeks, it was very horrible. I just didn't attend any session. I just concentrated on maths and statistics. Statistics also just for passing, and English and CT I didn't even see to it. Just attended graded assignments. And then ultimately, what I observed is that it was from week 5 onwards, the CT level increases the difficulty. So now I am comfortable with only for working professionals. They can just go for 1 subject in 1 sem. That's what I.
But then you would also want to finish it on time, right? So I'm taking 2 subjects at a time. And my experience, I've given all the quizzes. I've tried to cover up most of the sessions. If not live, then I would watch those sessions on weekends. So, for a person like me who has actually invested a lot of time, but then when you say that new rules have come up and they will grade only if you're attending it live, so it becomes a little discouraging. I know there is learning. Learning is important, and I'm putting so much effort because learning is more important for me. But when you get good marks and good grades,
If I take
it
only one
encourages you
per
to put in
sem,
more
Of
effort.
course, I don't say grades are not important. Grades are definitely important. It will give you a boost up to
So
get
that's where
into.
I feel, the playing field is not fair. So if there are bonus marks for grab, I'm putting in so much effort in this course that I've attended every quiz I have, even with 2 subjects and working. I must have attended more than 50% of the sessions last term. So there it feels unfair, when the playing ground is not level. If there are bonus marks for upgrade for grab, I would definitely try my best to get those as well.
Right.
So that's where I'm coming from when I'm putting this concern
at
across.
time of qualifier, sir, we cannot even go through each and every videos and each and every material. Now this time I went through each and every video, each and every practice assignment, and now I realize that the material is A1. But yeah, for qualifiers, we hardly get any time to go through each and everything.
Understand. Yeah.
So just if you could, pass on this. Of course, I understand that this is not in your hand, but I think just letting you can speak to someone and
Correct.
if something could be done.
These
Yeah.
bonus marks and whatever the changes you are going to see, it's like what we say is like what we on a larger scale we used to see, right? On or the inputs came from the previous term batch students or whatever the inputs we get. That is where, right? Whatever the data we have,
right.
From that data we actually come up with new sort of models and everything. We will implement on this new data which are
Sure.
new.
Thank you, sir. Because I just wanted to bring you to notice that I'm putting in effort, scoring decent
correct.
marks. But if there are marks for grabs, bonus marks, I would want to take those also. Because I'm putting in effort. If I'm watching all the videos, even if it is on YouTube.
Correct. See,
If
even
I
we are
have time, I
up,
will take it out for
coming up with
attending live.
I think that is true, sir. It should be other way around. I think working people, if they submit, their proof of working, I think they should be given bonus marks.
Working people can go only
No,
with
that's what not I was saying. I don't want any concession. But when it comes to the playing field, it should be even.
Even. I understand. Yeah, see, these are the inputs we take from you and we will just put it and we will improvise our data we have. We will come up with a new model. Maybe you may like it in the next term.
See, the
Thank you
other
so much,
thing
sir.
Yeah, thanks.
This bonus are for qualifier exam also?
No, see, that is what I said. It doesn't make you qualify. Once you qualify, or it is for end term exam. So once you are going to get
only for
a grade for a course, instead of getting B or C or lesser grades, if you have performed attending live sessions or answering in discourse or submitting practice assignments, submitting graded assignments, then you will get some sort of bonus. Adding that bonus, your grade will increase. That's it. Nothing much.
No, I don't understand one point. There are some people who said they have qualified in the October last year or something, and then they are still continuing these sessions. I don't know what is the purpose of doing it. Are they?
See, once they qualified in October, there is no need of taking all the 4 courses of foundation at that term itself. So they might have done 2 courses. After completing that 2 courses, another course in the next term. Maybe after completing 3.
Yeah, it's my case.
Yeah.
Sir. I did Intercity in October term, and now I'm just concentrating on maths.
So yeah, he will be a term student. So term means he has completed 3 courses already. He has qualified in October. Now in this particular January term, he is only doing mathematics. So for them, there will be quiz 1, quiz 2. So for you qualifier, for them that will be quiz 1.
Okay. Got
So first quiz. So they are going to give their first quiz of mathematics. So you are going to give the qualifier paper.
Okay.
Sir, one quick question. Sorry to ask you. Is there any, I don't know how to even join the discourse platform.
Discourse.
Yes, sir. Same problem.
Okay.
Discourse is also for term students. You get once you finish at least 1 term.
Okay, you are qualifier guys. Huh? You have that discussion forum, right?
Yeah, yes, sir.
So discussion forum is for qualifier people, and discourse is for term.
Okay, got it, sir. Thank you.
Okay.
One question,
Once
sir.
you qualify, you will get an ID, student ID. With that student ID, you can log in through discourse.
Sure.
Sir, is there any negative marking for qualified?
No, definitely not. We don't want you kick out.
Okay. See, much worse than negative mark is choosing a bad option, and then you get, the entire thing goes out. Let's say if you choose 3 options, there are no step marks, so it's either 1 or 0.
Sir, I observed one more thing is that in the graded assignment, there are 2 options correct. If you choose more than 2, 3, it will be considered as 0. If we option we give only one option, 0.5 is come.
Have you played this game Minecraft?
No, sir.
I have played the game.
Right.
I know what you are suggesting, what you are referring to.
Yeah. So there will be a grid of some sort of grid of some table, and each of there will be some bombs. Some places, some boxes will have bombs, but we don't know at what places they are. You have to choose all the rest of the boxes without touching this particular bomb. Okay.
Sir, in one option is correct. Remaining 2 option, second option, I choose other options. More than there are 5 options, I choose only one correct. Remaining 2 are wrong. So in that case also it will be 0.
Yeah, that is what I said. In this game, what happens is once you choose a bomb, your game is over. Okay, you have to choose each and every boxes other than these bombs. Each and every these boxes to get the total score. So once if you are done with choosing all these boxes only, you will get partial marks. Once you have chosen one bomb is like in our question, if you have chosen a wrong answer, whole game over, 0 marks.
Yeah, okay, sir. Thank you.
Yeah. So if you are not that confident about that particular option, don't choose it in MSQs. Okay, it will actually give you partial instead of giving 0.
Yeah.
Okay.
Yes, sir.
Don't choose bombs. So that is what I suggest. It is better choosing few blocks than choosing a bomb. Okay.
Okay.
So that is how it works. Okay. Then it's been a long session, and thanks for joining. And
thank you so much, sir.
Thanks for taking your time and explaining everything. Thank you.
Thanks. So another session is on Thursday morning 10 to 12. Please do join. Thanks.
Thank you, sir.
Host.
I think you are now host. You are now host right now.
He left.
Okay. Goodbye. Thank you.
Okay. Thanks. Bye.